chat status. Let me know when you're ready, and I'll start your 8-minute timer for your opening.
Yeah, send it. All right, I'm good. Well, I guess I'd like to preface by saying that never done anything on this level of formal kind of debate. Generally, I talk to people on Discord. And also, my beliefs, albeit are grounded in reality, and I'm going to be as honest as I can. I haven't, I wouldn't try to listen to the spirit of what I'm saying, perhaps, and not to hang on to every single syllable and word, because I haven't taken this opinion and really try to flesh it out for every single ounce of detail. So, with that in mind, my sentiment is more or less the kind of quote I provided by Werner Heisenberg. He's is attributed as being one of the fathers of quantum mechanics, and the Heisenberg uncertainty principle is named after him. Primarily, the quote goes, the first gulp from the glass of natural sciences will leave you an atheist. At the bottom of the glass, God is waiting for you. And the reason I believe that sentiment reflects my opinion is because I didn't come into this space being a theist. I didn't come into the space with any religious predisposition. I wasn't someone who went to church or had a deeply religious family. Matter of factly, if you were to speak to me 10 years ago, I'd lean very heavily towards atheism. And at best, I could crudely say I believed in pantheism. But after having delved deeply into physics as something as it's a passion of mine, and just continuing to accrue more knowledge through that investigation, I came to the realization that what we call God, the properties that are attributed to God, is something that is unignorable. You cannot deviate from it. Now, in the most crude sense, what I'm trying to say ultimately about the natural sciences pointing to God is mechanistically, we have derived many things about the world that have practical use to us. Like, for example, this conversation right now is being mediated primarily by the electromagnetic force and our ability to manipulate electrons to such a high degree of accuracy that we can not only have a video stream, audio stream, but coalesce it all together and project it to a broader audience while all of this is happening, synchronously across the planet in virtue of satellites and everything else therein. It's pretty magnificent if you really think about it. And a lot of people having this ability to manipulate this force, they've kind of almost deceived themselves into thinking that we understand it as the causal nature of it, understand it, and a sense of why, not a sense of how. When it comes to the how of electromagnetism, we again have a stupendous understanding of it. That's why we're having this conversation. Now, the deeper question I find is why? Why is there a law of electromagnetism to begin with? Why do there appear to be some delineations in physics that are immutable and non-causal and non-inferential in any sense? And for a time, I thought that there was some degree of explanation to this in physics, that if you just continue to peel the onion back, ultimately you could peel the onion back far enough to understand, okay, this is what it's pointing to, and this is where this emerges from. But I was unfortunately somewhat disappointed by this, because no matter what model of physics you subscribe to, whether it be Big Bang cosmology, inflationary models, field theories, pilot wave theories, quantum field theory, kind of all in the same domain, whatever angle you seem to look at the physical world from, you come to an irreducibility of there is something fundamental which is non-emergent. And the non-emergent fundamental essence of that thing is immutable and infallible, that you can't understand it or speak of it as coming and emerging causally, and you cannot understand it as being any other state of affairs. And I guess I'll save the further explanation of this when or trying to get more into detail about this, but for the later part of this conversation. But in essence, if you perceive my worldview, what I'm saying is that if there is some body, and when I say a body, I mean body in physics, like a singularity or some homogeneous state of affairs from which you're saying the universe emerged from, you're ultimately at some point in time having to apply some irreducible force gradient or some irreducible um, polarization of even degrees of freedom in some sense that need to be applied to it, such that through that mechanism the homogeneous body undergoes a phase change. And the phase change in this case, for example, would be something like the singularity expanding into space-time and leading to what we call, generally speaking, Big Bang cosmology, or at least that notion. And it inserts this seed that so many people overlook and don't attribute any value to, that there is some delineation, like some this and that, like as if there was sand and someone drew a line in the sand and separated one region of it and another region of it and said, this separation is immutable, infallible, and in virtue of that separation, then you can argue things emerge from that. And that's where physics comes in and starts to explain to you the hows and the models and the arguments as to how the strong nuclear, weak forces, gravity, etc., all of these things can emerge from this. But it gives no explanation at all as to why that line in the sand exists in the first place. And what really kind of turned me, and I guess this is the last point I'm going to say, really kind of turned me is reading Genesis and reading the first lines of Genesis. And it very clearly points out to the reader that the first act that God did was a separation. And it's a separation of two things that are diametrically opposed. It says that God created the heavens and the earth. And a lot of people take this literally, like in the sense that, like, okay, there's the heaven and there's the planet, and that's what they mean. But I don't think that's what is meant by the writers of this, because they proceed to tell you very explicitly that the earth is formless and darkness is over the surface of the deep. So they're clearly letting you know that what they mean by the earth is not actually the physical planet we stand on. And yeah, I guess let me just finish there before I start like divulging into too much of a ridiculous thing. But let me know what you got out of that, and if you understand, I guess, where I'm coming from insofar as my sentiment towards God, because it's not a religious thing. I don't want to be arguing or debating like religious
10 seconds.
perceptions of this. It's just more of like a philosophical idea. So yeah, that's it. Thank you.
Perfect. Thank you for the intro, and feel free to ask Eric those questions. And don't forget, audience, I have 50 pieces of clothing on. We're trying to get to 50 likes. I'm removing a piece of clothing for every single like we get. So let's make sure we get up to 50 likes, people. Eric, let me know when you're ready, and I'll start your 8-minute time.
In addition to autographed copies of both my books, and of course Spanky, I'm excited to announce that I now have stickers, tumblers, apparel, and more on my store. Take Spanky, the God-defeating penguin, and can you put that into a logical syllogism, with you wherever you go now. Very soon, I will also have Spanky Bibles and some more stuff coming out. So if you want to check that out, it's in the description. Thank you.
First of all, this is my cat. Okay, second of all. So the topic is, do the natural sciences point to God? My position is that they can't, not just that they don't, but like they literally cannot do this. Natural science, it is powerful, but it has pretty strict boundaries. It can describe the natural world, test hypotheses about how it works, and refine those models of reality that we come up with. But what it can't do is it can't point to any kind of supernatural reality, because the supernatural lies by definition outside the domain of what science can test. So science deals with, again, observable, measurable, and things that are testable. A scientific theory, for example, it has to make predictions that can, at least like in principle, be checked against some kind of evidence. It doesn't have to be, there can always be technological limitations. Famously, like with relativity, these weren't really confirmed with observations and experiment until many, many, many years later. but it was eventually done. And an idea to be considered scientific, at least depending on who you ask, most people think that it has to be falsifiable. There has to be some way to prove it wrong. And also, it must be naturalistic, meaning that it appeals only to natural causes, because those are the only kinds of causes that we can actually study, that we can understand at some level, and eventually by pursuing science, we can understand them at deeper levels. So it's not an arbitrary rule. This is what gives science its reliability and its just unprecedented record at discovering true things about the world we live in. When you get into an airplane, or when you take medicine, or when you send a text message, you trust science because it restricts itself to those testable claims, and the body of work is right there in front of us. So faith, quote unquote faith in science, is trust in a process that we're all exposed to at some level, and that anybody, at least in principle, can participate in. But God, if God or gods exist, that's supernatural, and it's beyond nature. Depending on who you ask, it's beyond time. It's beyond any kind of physical laws as well. So by definition, that puts God outside the scope of what natural science can detect. Faith in God is the belief without evidence. It's personal, and therefore it's unobservable. It's not shared, and I don't think it's epistemologically, I don't think it has any epistemological worth. So some people sometimes respond to this by saying, well, if God created the universe, then science ought to be able to point to God. And famously, early scientists like Galileo and Newton and many others thought that they were, uncovering God's majesty or God's creation right before us. The problem with that, if you ask me, is that no version of any God hypothesis can function as a scientific theory, because it doesn't generate any of those testable, falsifiable predictions. If the universe is orderly, you can say that that's evidence of God. If the universe is chaotic, you can also point to that and say, well, that's God working in mysterious ways. That's a mystery of faith. If life is very simple, that's just the way God would have wanted it. We can read God's intentions into anything we see. Or the opposite. If life is complex, we can say, oh, behold the majesty of God and his works. Another problem here is which God, how many, are they personal? Are they impersonal? Are they limited in any kind of way? Do they have no limits, etc.? So a classic example that I run into quite a lot is with creationists. So they'll argue something like, well, the universe looks old because God made it look that way. So we have a God explanation in spite of the natural sciences, not supported by it in any way. You can turn around and then ask the creationist, oh, so if we could only see 6,000 light years, which is how old they say the universe is, and is the actual number the only number that would make any sense. So ask them, if we could only see 6,000 light years, then would that be evidence your God doesn't exist? And with that, their minds explode. They have to admit that that would also prove that their God exists. So it's just the game of I win from Big Daddy, except it's not really very funny in this case. So what I'm saying is, in other words, no matter what data we find, the God explanation can be stretched to fit it. And if a theory is compatible with every possible outcome, then it's not a scientific theory at all. It's not a theory. It's not an argument. I wouldn't say it's even philosophical, because it's just corrupt at its core. Now, it's true that many people look to science and feel it points to God. The host did, or the host, my guest here was doing some of that. So I was taking notes, so I'll probably just skip over this for my intro, because we'll talk about this in the opening. I'm curious where this is going to go. I think we're just going to be not backtracking, but sort of retrofitting a God explanation into all of that data. And this kind of thing has a historical precedent. History gives us all kinds of examples of people trying to use gaps in scientific knowledge or scientific discoveries as evidence of God. So, for example, any natural disaster or phenomena you can imagine at one point was said to be the work of God or gods. This still happens today. Christian monotheists. They claim God made it rain to save the crops, or sent the 2004 tsunami to warn everybody to, hey, quit being so gay. I mean, I shit you not, like Pat Robinson, he actually said that at the time. So in each of these cases, invoking God as a scientific explanation, it didn't hold for those things. A naturalistic explanation superseded it and explained it, I wouldn't say fully, but satisfactorily. I don't know if that's a word, to the point where God becomes unnecessary. So this doesn't like disprove God in any way, really, but I think it demonstrates that the God hypothesis, whatever we want to call it, it was working on nothing. And every time we discover something about nature, it never has anything really to do with God. So what's that? Okay. My challenge for my opponent is if you can give me one single example of a discovery in the history of mankind, preferably concerning natural science, that was proven theistically. If that can be done, I don't really think it can. Let's see here. Well, since I'm pretty much out of time, last thing I'll say is, blurring the lines between science and theology, I don't think it really does too much justice for either one. Like, if you want to argue God, I think you should use philosophy, metaphysics, theology, or something like that. I don't think anybody's ever had any luck doing it that way either, but I mean, those are at least valid modes of reasoning. But if you want to argue that from natural sciences, rather, you're restricted to natural explanations, and I think God just kind of by default falls outside of that. So, perfect. Yeah.
That being said, I am excited for this debate. I think this is going to be a ton of fun. Do y'all have any questions before we move into this debate portion, or is this pretty simple? This is going to be just a back and forth, y'all, and then we'll take a vote at the end of it after the closing statements. So let's go ahead and move into this. I'm going to start the timer here in just a second. Y'all will have 1 hour to discuss, plus whatever time from the super chats. We did get a couple actually, so let me get those pulled up. Okay, I'm starting the timer now. We'll start with the first super chat. Question for Peterson: would you be down for a 2v2 debate, Peterson and Grayson versus Ben and Grace Thorpe?
Are those people you messaged me about?
Yeah.
Okay. Well, that's a super chat.
You can say yes or no and not go into detail.
Yeah, I would say almost certainly not.
Gotcha. All right, y'all do your thing.
All right.
Yeah, go first.
I appreciate you for the thank you, my friend. Now, from Professor Hizzle, I think I see that. Now, I heard your question, and I'd like to just point out two things so we kind of don't stray off into something. I'm not a young Earth creationist, so I don't think the universe or the whatever 6,000 years old. Also, when I speak of God, I speak of him as a ontologically necessary being, in the sense that there's a set of properties that no matter what point of view you look from, whether it be from a theistic, philosophical, or a physical perspective, a natural sciences perspective, there's a set of properties that are unilaterally accepted and necessary. And that is why I hold the theistic position, because I would ask you, before we speak of whether this entity isn't or whatever, we have to somewhat identify what it is that we're looking for, right? We have to get a fingerprint of it. And before we speak of God's omnibenevolence, his will, his ability to communicate with you, or whether or not he hears your prayers, all of these things are tertiary to the fundamental proposition of God's nature, which is the nature of being unbegotten, non-causal, or non-contingent. These are all synonyms for the same concept. Effectively speaking, that when you speak of God, you're speaking of that primarily. And if you were to say God is causal, a causal agent, or something precedes him, it therefore you're no longer ontologically speaking about God. Like you can use the word God, but the properties of that entity no longer meet the ontologically necessary set of properties attributed to it. It would be equivalent to saying a square with 5 points. Then, I mean, you can call it a square, but a square necessarily has 4 points, ontologically necessary set of properties. So are you following me when I say this proposition?
I think I follow probably like 95% of it. My question is, this all sounds very meta. I don't see how this are you just trying to establish what you believe in because you don't want me to like throw you in with the young Earth creationists and all that stuff, or do you think that this somehow is part of the pathway toward how God is relevant to natural sciences? Because I don't see how it is.
Both. Yeah, both. I think that
Okay.
first it's very important to establish what I mean by this word, and then
Sure.
how that word relates to the natural sciences and its set of properties is related. So,
Okay, well, I would ask for you to give the case of how God's philosophical definition or whatever about being ontologically primary helps, is in evidence thanks to science, or helps us in some way do or understand science.
Exciting news, I will be at DebateCon in Nashville this November. If you're in the area, click the link in the description to get your tickets. There will be meet and greets, VIP events. I'll have copies of both my books. I'll try to bring some Spankies with me, and you get to see what I do in person. Once again, link to the event with schedule, tickets, venue, all that information is in the description, so please check that out. And I'll see you soon.
okay. As far as do and understand science, it really goes back to the oldest pioneers of the scientific method. Like, they were all theists, and many people say, well, they're theists because everyone was a theist back then, so you're just selecting from a pool of theists, so naturally you'd get someone to make science who's a theist. But I'd say that it's a further supposition they made that if you assert there's a lawgiver, then there are laws you could understand, and these laws could be inferential into the future. And that fundamental premise is what gave rise to the concept that we could even map these laws in a faculty such they're predictive and useful.
Sure.
And so that's why I think that. Now, I also think it's quite evident that this belief of it being non-emergent is ubiquitously held across the Abrahamic school of thought. So I try to give people this analogy, right? If you take theater and everyone from the Abrahamic school of thought, which is the predominant theistic group of people. Like, I'm not talking about Hindus or whatever. I'm speaking from the Abrahamic school of thought, and that's what I'd like for you to address in this conversation. But the point is if you take anyone from that school of thought, whether it be your Jews, Hasidic, Sunni Shia Muslims, Catholics, Baptists, Protestants, you name it, whatever the case is, you fill them up in this amphitheater, they would be at odds with each other about everything, about the clothes they wear, the food they eat, the way they're allowed to dress, the holidays that they participate in, etc. Right? However, if you stood in the center of this amphitheater with a megaphone and you asked, where does God come from? Every single head would turn to you, and in unison, they would say, God does not come from anywhere. That is the fundamental assertion of the Abrahamic school of thought, is the necessary set of properties attributed to him.
I mean, I think today it is, but that the Abrahamic God, as created and written about by ancient Hebrews, I don't think they would have thought that at all. I don't want to really get into a theological discussion or a discussion about the history of the Old Testament, because again, that's very meta and not really the subject of what we're doing here. But there is something you said that I wrote it down that we can work with here. You said if there's a lawgiver, then there are laws. That was the logic of the early scientists.
Yeah.
If the universe, well, do you agree that the universe is governed by natural laws, like the laws of physics, fundamental constants and forces and things like that?
Yeah, appears to be.
Okay. Then if that's the case, then wouldn't there be discoverable? Then wouldn't we be able to do science if that was the case?
We would be able to do science, but when you begin to do
So
science and you begin to pull the layers of that back, you come to an assertion that carries the same set of properties that you attribute to God. Meaning, at its core, to do science is the assertion that there is a set of immutable, non-causal, infallible set of rules. Then
oh,
I say to you, from the theistic point of view, what are the primary attributes of God? They are being non-causal, immutable, and infallible. So if you were to draw a Venn diagram of the assumption of the set of properties you assume in physics fundamentally, and the set of properties that are ascribed to God fundamentally, there's an unignorable overlap between these two.
yeah, I'm with you on almost all of that except the leap you make to the end when you say that ultimately it takes you to something that is fundamental and immutable, right? And that's the same as God. I don't actually think that science does that. So, for example, science is in this. Physicists have been extremely frustrated at our failure to be able to create a what do you call it? A theory of everything, right? Like a grand unified theory. Because for all we can tell, and this is what I mean by it's not the fundamental the constants and all those sorts of things that you've brought up, and that I don't know if I really brought them up, but that we both agree exist. Yes, the universe that we live in and that we experience does seem to have that property, but it's actually probably not immutable because, like, for example, before the Big Bang, we think that probably all those fundamental forces in physics would have been unified, and we don't know what that unified theory looks like. But so these things that are immutable actually aren't. They can actually be transformed and changed into something else. And then
So
go
I
ahead.
hear you. Can I interrupt you there for a second? Because
Yeah.
that's exactly the same roadblock I came to, right? That like, okay, well, there's there four fundamental forces. It used to be five, and we merged magnetism and electricity together, and we understood that same force. So now we have four. And then we argue that if you reduce this down to Planck space, then at a certain point in time, the ability to delineate one from the other stops, and therefore the forces unify into one. However, that singular unified force is not homogeneous. It has a delineation, whether it be in, uh, you're talking about a gradient upon which fluctuations can occur. A gradient implies that there's some position here and some position there, and there's something in between. There's an oscillation that can be measured. If you look from the perspective of the electronuclear force, it's diametrically opposed, just like electromagnetism is. It has a positive and negative end between which a potential is catalyzed. If you're even talking about um, like quantum mechanics, you're talking about the ability that for there to be a spin, even right, in some of these models. And a spin is again the delineation between having one set of properties and another. And so the issue with physics is that if you assert that there's a homogeneous body, like a singularity, all space-time exists within it, it is homogeneous, there's no gradient of delineation of any kind, and there isn't a force, internal or external, acting upon it, it would just remain a singularity forever. There would be no mechanism by which it would undergo a phase change. The argument of physics is that it does undergo a phase change. And for it to do that, you make an assertion of a fundamental force or some freedom of spatial freedom that is immutable, that doesn't come from anywhere, it isn't derived. It's just you say that this is where the starting point is, the beginning. And from this beginning, then you can make some sort of inferential, then this happened thereafter.
Okay, so I am not a physicist, so I'm not really qualified to talk to you about what we think may have triggered the physicists are I do know that they very much disagree about whether true singularities can actually be a thing. But I mean, like with respect to the universe, as far as causes, quantum fluctuations are often invoked. It has something to do with virtual particles popping in and out of existence, and that can trigger I don't like inflation, and then that leads us to a big bang or whatever. So, I'm not really qualified to sit here and argue with you about, well, is the causal mechanism behind what happened purely internal? It has no outside influence or anything like that. But I guess I am still kind of so. I mean, we did the law and lawgiver, and then we did getting to things which are immutable. I guess I'm just probably going to go back to in what way does any of this point to like an actual God?
Well, again, the way it points to a God is we must first understand the quintessential properties of God before we tack on everything else about his will, omnibenevolence, his communication with you. Everything thereafter is tertiary, right? It's derived from a fundamental set of principles. And my assertion to you is that we investigate those fundamental set of principles honestly. What is being said when you speak of God? Fundamentally, what you're asserting when you say the word God is first and foremost something non-causal, non-contingent, non-emergent. That's the first set of properties. Then derived from that necessarily is that since God is himself and solely himself, then it would be the case that he would know himself perfectly and would be infallible to himself since he is himself fundamentally. Like he is 100% himself. It couldn't be any other way that he knows himself perfectly and is himself perfectly. And so these are the three tenets that we ascribe to him. Again, non-causal, immutable, infallible. And so I say, then you investigate physics. You say, well, I'm not a in-depth student of physics, but therein is the title of the room and why I even brought this proposition forward, is that exactly as Werner Heisenberg said, if you take a gulp from the School of Natural Sciences, which of you admitted to doing, you're not formally educated in this, you haven't investigated this to its depth, you come out an atheist because you presume our explanation of this is sufficient and sufficient enough such that we can launch satellites and we have thermonuclear reactors and we can talk through the internet. Well, obviously we must understand this, right? But if you continue to investigate this and truly understand what is being assumed within these models, you understand that the properties given to the fundamental assumptions made in these models are identical to the set of properties ascribed to God fundamentally. Therein is why Werner Heisenberg, the father of quantum mechanics, made this quote. It's because his understanding of this field was so in depth that he could not ignore the parallels between these two schools and these two principles. And initially, you asked me a question about pointing out, insofar as some of the propositions made by theistic claims and seeing whether or not these propositions made by theistic claims have been validated in any sense. Now, do I think you can test the Bible in a scientific, repeatable fashion? No, I think it's a testimony and account, and it's observational. Beyond that, it's no experimental thing we can conduct on it. But it does make some pretty bold assumptions for the time that it's supposed to be written in. First and foremost, it asserts you have free will. And it asserts this fundamentally and says that this is the state of the universe irreducibly. And for the longest time, physicists, going back to the 1700s, even the 1900s, were making bold assertions that no, the universe is deterministic. We can know all initial conditions. And if we do know all initial conditions, we can therefore literally predict the future in the most literal sense. And we can foresee every causal chain going into the future. And this was the long-standing belief of physics for centuries on end. Okay. Now, in 2022, Nobel Prize in Physics was awarded to Anton Zeilinger and two other guys that worked with him. And I don't know if you're familiar with Bell's inequalities or Bell's theorem in general.
Demonstrated non-locality. Yep.
No, they didn't demonstrate non-locality. there's only one of two things. There's one or two things that need to be negated. Either realism, in the sense that something has a set of properties prior to it being measured. That's the state of affairs. Or that there's some transfer of information that happens faster than the speed of light, which violates locality. You can only have one or the other. You can't have both. Now, the reason it isn't locality, and we aren't removing locality out of the equation, because that is the most fundamental assertion of physics, meaning that the speed of light cannot be violated. And if you assert that the speed of light is violated and the rate of information transfers faster than the speed of light, you literally need to take all of physics, throw it into the trash can, and start from scratch. So nobody's willing to do this. Nobody has
unless you
sufficient.
adopt a many worlds interpretation of quantum mechanics.
But a many worlds interpretation of quantum mechanics simply deals with the measurement problem and the collapse of the wave function according to the Copenhagen interpretation. And the Copenhagen interpretation is the most sound and most held belief in quantum mechanics. And many worlds interpretation.
It's the majority, but serious scientists hold to it's called the Everett interpretation. It's named after a physicist. I don't remember his first name, but there are other prominent physicists like Sean Carroll who consider themselves many worlds. But
okay, well,
that's
explain
basically a
to me
metaphysical interpretation of the nature of the wave function collapse. It's really at the end of the day, there is going to be a philosophical, I don't think opinion's the right word, but a view that you have about the nature of that.
Can you explain to me, without ChatGPT or like reading anything off screen, because we can see your eyes moving, can you explain to me where the many worlds interpretation comes from and why it even exists?
Well, it comes out, so I can't really tell you very much about it, but it comes out of what I would say is it comes out of the physics. There are interpretations where their interpretation is just something about every time at any possible measurement for the wave function collapse really does manifest itself, I guess, in some kind of reality.
Okay, many worlds does not assert the wave function ever collapses, so you're a little bit off on that. Secondly, it deals with what is called the measurement problem. To the audience, you're free to go to Google, type in the measurement problem physics, read all about it. The measurement problem is the issue of the collapse of the wave function, that there's two distinct states in which we measure a set of anything, whether it be a subatomic particle, baryonic matter, even leading up to things as large as a buckyball, which is 64 carbon atom structure. Ultimately, the point is that there is a phase change. Something appears and actually is as a probability distribution, not that we just map it mathematically, but it actually manifests as such. And then upon measurement, many people think measurement is like you looking at it or your consciousness interacting with it. No, it's just the assertion that some classical object has interfaced with this and thereby caused the collapse of the superposition. This measurement is what causes this collapse. Now, the collapse issue and why it's called the measurement problem in physics is because there appears to be a phase change that isn't catalyzed by anything. So in the standard model,
what do you mean by phase change? You keep saying that, and I have no idea.
A phase change between it being physically as a probability distribution, a wave, and then that wave collapses into a point particle.
Okay.
That's what I mean as a phase change. There appears to be this phase change that isn't catalyzed or is not measured temporally. There is no subatomic particle that interacts and gives rise to this. So, for example, in the standard model, every single faculty of everything we observe, from the electromagnetic force to the nuclear forces to gravity, or even mass, not gravity, but what gives rise to mass, every single one of these forces has a gauge boson, which is effectively the subatomic particle responsible for the force mediator. It is what actualizes the force. The electricity is the simplest explanation of this. The electron is the thing that catalyzes the transfer of the force of electromagnetism. And that's why you can say, oh, this is physics. This is boom. This thing does this thing, and then we get an outcome. The issue, and why in physics it's called the measurement problem, is because we observe a phase change, but we cannot pinpoint it to anything physical or even temporal. It seems to occur instantaneously. And so therein is the Copenhagen interpretation. The Copenhagen interpretation is that the wave actually collapses. The many worlds interpretation, which many people kind of cling onto and don't truly understand the depth of what's being asserted here, the many worlds interpretation is merely a mathematical solution to this problem. It's the assertion that the wave function never actually collapses and that it's just existing in another world.
Yep.
And in doing this mathematical trick on a whiteboard, they can negate having to deal with the actual collapse they observe by asserting there's an infinite plethora of perpetually generating other worlds within which those wave functions exist. They just appear to collapse in this world.
Yeah, it sounds pretty wild. And in the other one, for some reason I can't remember the name. In Copenhagen, the cat is both alive and dead at the same time. So I don't think one is more fanciful versus the other, and neither one is really provable or disprovable. I can't go get you many other worlds to demonstrate that the Everett interpretation is the correct interpretation, and you can't give me a superposition of a cat that is both alive and dead in this world.
But I can give you a superposition of an electron, though. I can't do that, right?
You can give me a superposition of an electron?
Right. So why are we dealing with cats then? Because cats are classical objects. So if we're dealing with quantum mechanics, we have to deal in the domain of quantum mechanics. And in that domain, superposition is not something on a whiteboard. It's something we literally observe, deal with. And it's so real, matter of fact, that we have qubits, we can entangle them, and we are working on functional quantum computers because of how real this property is. It's not on a whiteboard. But when you talk about the many worlds interpretation, it's quite literally a mathematical solution demonstrated by nothing. And to those who understand what it's solving for, as I've attempted to explain to you, they understand that it's really just a sleight of hand. It's really all that's happening.
Do you not
You're
know
not
about
really
Schrodinger's
doing anything.
cat?
Of course I know about Schrodinger's cat, but
Okay.
Schrodinger's cat's a thought experiment, brother.
Yes,
Like nobody is asserting that
it's
something.
the logical conclusion of that Copenhagen interpretation. The cat is both alive and dead at the same time until you look.
No, until you measure. It's a thought experiment.
Yes.
Quantum mechanics deals with things that are subatomic. Once you
I
have
know
enough
that.
things, okay, so then there could be no application of quantum mechanics to a cat ever. Why would
no,
we?
yes,
It's a
there
thought
absolutely can,
experiment.
because the cat is part of a system in which it's part of a system in which it's intertwined with the cesium atom. But I did not sign up for a discussion on
not.
quantum mechanics. I know a guy that's an actual physicist who you'd have a much more productive conversation with him on this. I just here to talk about,
Well,
does natural science point to God in some sort of way? So
right, but that's what I'm saying to you is if you keep on reiterating back, let's just go back to the surface level, then you'll never get to the proposition. The quote that I cited to you is the first gulp. You're sitting here continuing to tell me that we just ought to take the first gulp and that's it. I'm saying to you, brother, do the work, make it to the bottom of the glass, understand what's being written in these models,
that
and
quote is
God
a
will stare you in the
fabrication.
face. Okay, well, if you want to have some malaise, like surface level conversation about physics, I didn't sign up for that personally. I'm not particularly super interested in doing that. And I'm trying to explain to you that if you delve into the depth of these models and not just talk about them on a surface level, God will stare at you. And so I'm unwilling to go and retract
what
all
does
the
that
way
even
back
mean?
to some
God will stare at me.
that the properties, again, that I alluded to you, that something is non-causal, immutable, infallible, that these are the three properties that you're looking for. And if you can find something with these properties, it's a very strong argument for the set of properties attributed to God. And so
What makes you think that the immutable laws of nature possess infallibility? What does that even mean?
well, it's an axiomatic assertion. It's not something we demonstrate, practically speaking. There's no scientific experiment I know for
doesn't
this,
sound
but
like natural
the
science.
well, I'm saying to you that the uniformity of physics is an axiomatic assertion within physics. meaning that like the argument that electromagnetism functions like this here, and therefore it functions like this in a star, in the Andromeda galaxy, or in Mom Z14, the oldest galaxy we have currently observed with James Webb, 280 million years of the supposed Big Bang, the assertion that electromagnetism would function exactly the same way there is an axiomatic assertion of physics. It's not demonstrated experimentally. It's just a necessary assertion. Because if you say that these things are different everywhere, then I mean, at that point in time, like the physics you can do is just limited to planet Earth, and that's it. But we claim to be able to make arguments about the nature of a quasar, the nature of a black hole, the nature of etc. in things that are hundreds of thousands, millions of light years away from us. Why is that? Because in physics, there is the fundamental assertion that there is infallibility and uniformity that is applied to these laws across the entire universe.
Yeah, we talked about this earlier. If a universe has those things, then we don't have to appeal to anything other than those laws and constants in nature. So I don't see how it points to God. I guess.
And there is a super chat related to that, actually, before moving on to the next topic. Bendova, thank you for the super chat. They're asking, so where in all this babble does God hide? I think they were referring to the quantum speak you were going through.
Yeah, okay. In the babble, where does he hide? Well, he hides, if I lean into your question, in the sense that, once more, the thing you're looking for is an infallible, immutable set of things, or an entity, right? And so I say to you, in quantum mechanics, for example, there from simply a quantum mechanic argument of like inflation, an inflationary model, there is the assertion that there is degrees of freedom that are non-emergent, and then there's the argument that there is a fluctuations upon which implies a gradient, meaning that if you have a completely homogeneous system, there's no fluctuation because one is inseparable from the other. But to make the argument that there could be a fluctuation is the argument that there could be a delta, some change that can be measured. And that change implies that there's a gradient to which you are pegging the change, which makes the assertion that the gradient is more primordial than the actual fluctuation. Because for the fluctuation to emerge, there must be a gradient. And so then the assertion is the gradient is somehow infallible, immutable, non-emergent. And then I say to you, okay, well, if you call it a gradient, that's fine. But descriptively, you're talking about the same thing. And so I bring this analogy to you, right? Like imagine you to me right now, we're explaining a set of properties like equilateral sides, a 90-degree angle necessary and has 4 points, right? And you called it a philamagon or some nonsense like this, right? And I said to you, wait, the philamagon is identical to what we call a square, and that you came up with the word philamagon just recently and attributed the set of properties to it.
No, that's exactly what I was going to do with you with respect to God, actually.
Yeah, but the set of properties attributed to God and the assertions made therein theistically seem to be far more primordial than any assertion of physics. And if you were to investigate,
changed over time. Like if you ever read the Bible, God, this is I think I've talked for a total, apart from my opening statement, I think I've talked for a total of maybe 5 minutes here. So I'm going to try to get some questions in here. Does God ever change? Does God change?
Sorry, you asked, does God ever change?
Yeah.
No, that would make him mutable. Okay, so he was immutable.
The universe does change.
The universe is relative. Yes, we appear to see time change, the rate of change.
I don't understand how the universe would be reflective of a God that doesn't change. Then, because if you say,
well, the set of laws that govern it.
No, those definitely change. Yeah.
The set of laws change?
Yes, because where inside of a black hole, for example, or before inflation, for example.
So they unify. Okay, a unification, you're arguing is change?
Yeah.
How's that? I'm confused as to. First of all, I'd like to point out that the assertions we make
Because
about a black
there was
hole
no
are
space-time or
purely theoretical.
electromagnetism before the Big Bang occurred, as far as we can tell. So these things
Yeah,
that are
sure, that's the assertion
fundamental
we make.
were not there.
Well, first of all, when you say we can tell, this is purely a perspective of a model, not observational in any sense. Matter of factly, the James
Those are
Webb
the
Telescope is
limitations we
doing
have
it.
of science.
Yeah, and so furthermore, anything you speak about in regards to the operations of a black hole are equally as literally philosophically a conjecture of mathematical assumptions. It's not like observable, testable, repeatable in any sense of the word. So
That
if you're
doesn't
going to hold this
make any
gradient of
sense.
science, that gradient of science doesn't meet the burden of proof for the unification of the four fundamental forces. That's just something we assert. Or the operations inside a black hole, that's also just something we assert. We have never experimentally verified any of this stuff.
Okay, if I stake a claim that fails that specific task you've brought up, then God absolutely fails that task. So was I being dishonest for saying that, but you somehow are not, or are we both allowed to do this?
Sure, you can do it. I'm just saying to you, if you're going to point out that for me, I just pointed out for the audience as well. I'm not stopping you. You can go on.
That didn't answer my question at all. The problem or limitation you just described to me making those claims absolutely applies to God. So was I being, if I was being dishonest when I do that, then you're being dishonest when you apply this also to God. Or
Well,
is there something else going on here?
right. My question to you is the difference is the claims made about God are axiomatic in nature, right? The claim of the unification of the four forces isn't axiomatic, it's a derivation. You're like giving set axioms, you are therefore deriving that there's a grand unification. The axioms I'm purporting about God are the axioms that are beyond metaphysically or ontologically or philosophically speaking about this. They're derived in that sense,
Okay.
perhaps.
What is your
through
method for
thought.
confirming these ideas?
Predominantly, insofar as the properties of God, this is largely to do with philosophy, I would say. This is
Okay, so I'm not really sure why we're having a discussion on the natural sciences. Then, if ultimately that's what. So, when I hear the claim that the natural sciences point to God, right? That's the topic. What's the specific topic?
Yes, it's do the natural sciences
Point to-
point to God,
Yep.
and also Bendova just responded to you. So universe be universing, so universe is universe. Got it.
Yeah,
You don't have to respond to that if you don't want to. But.
It do be like that sometimes.
I mean, if you really, that's the takeaway from what I'm saying. I think perhaps something appears a little off for you, but go on.
So when somebody says to me that the natural sciences point to God, to me, what it sounds like they're doing is they are making a claim that is in evidence, not axiomatic. So what are you actually doing when you stake the claim that the natural sciences do point to God?
Okay, right. So there is a set of axioms that God necessarily must possess. And I've repeated them like 5 times or 20 times over at this point. I don't even know. Those set of axioms can then be located in the physical world. And it is found in the assumptions made in the models in every single model of physics. That's what I'm saying to you, is that at the most core level, if you continue to peel the onions back of any model you have or take, there is some immutable, infallible, non-emergent principle at the center of that model. And what I'm saying to you is the first people to formalize the argument of something having this set of properties are theologians of antiquity. And they further made
scientifically ignorant. Yeah.
Sure, but they made some very, very bold claims. They said that we're inspired by, the true word of God and that somehow they had insight into this. But The point is that, for example, they made two very bold claims. One is free will, and the fact that
Which doesn't
determinism
exist.
isn't real. Well,
It doesn't exist under theism either.
I don't know. I don't. We can delve into that in a second. There's free will, and then there's another very straightforward assumption and assertion made that the first thing uttered by God is "Let there be light," and that is the first fundamental emergent entity in the created universe in the theologian worldview. And the first and foremost thing that was grounded and quote unquote proven by science, in the sense that these models assert the same thing, not that we experimentally prove this, but the assertion that the first state of the universe was nothing but energy, there was no baryonic matter of any kind, is the assertion of the Big Bang, is the assertion of any quantum field or expansionary model, is that the first thing is just raw energy. And raw energy, as we know now, is the segment of it that is visible to the naked eye is light. Now, we know the electromagnetic spectrum to be much broader than just visible light, but light is a part of that spectrum. And I think that the writing of this and the methodology that was spoken of in that time was obviously in scope of their understanding of the world. They didn't understand quantum mechanics. They didn't argue about physics, etc. And so they spoke in a very lay, very sort of like, they used analogies a lot, things like this to try and get their point across. But the point that they were getting across ultimately is then, thousands of years later, grounded in natural science. And it's the same assertion we make. And the reason I point to the 2022 Nobel Prize is because determinism has, the scientific community of physics has taken determinism, wiped their ass, and threw it into the trash can.
No.
It's absolutely
No.
in every sense of the word.
There's hard and soft determinism in physics, and the hard determinism in physics only fails Bell's inequality theorems if you take a Copenhagen interpretation. If you take a many worlds Everett interpretation, you absolutely maintain determinism.
Okay, so if that's what you really think is going on, then what is the reason behind why the scientific community would award these men a Nobel Prize for their work and argue that they created an absolutely loophole-free experiment, completely negating the ability for something, for a local hidden variable to exist? And that ultimately speaking, these the spin of the polarization, not the spin, the polarization of a photon is not predetermined in any faculty, or could be understood as there could even be a set of properties that would give you inference to the polarization of a photon. If they held to determinism and there was a perspective that gave an ounce of credence to this, why has the scientific community awarded a Nobel Prize to these men for their work?
It's still, no matter what interpretation you take, it's still an extraordinary accomplishment to have demonstrated that. And I remember years ago when it happened, I had some very nerdy people, physicists, computer scientists, and others explain it to me, and it has evaporated from my memory. I don't have a degree in physics or anything like that, but
it's very important, brother. This is very, very important.
Having a degree in physics is not very important. It's important for physicists, but
I didn't mean a degree in physics. I meant like understanding the work that they do and what it means, what is inside of the work that they produce.
Yeah, sure, that's fine. I want to. So this is backtracking a little bit to what we were saying, but you were talking about or I brought up unifying forces, for example, and you said, well, that's all, I don't know, like purely theoretical or whatever. Now, I did cheat. I used the Chat GPT to look this up. But we have actually experimentally confirmed that electromagnetism and the weak nuclear force do actually merge into something called the electroweak force. That has been experimentally verified.
Mm-hmm.
So that ties into the idea of
Yeah, and I'm
these
saying to you
forces, they're
that
not
that's
immutable. They
that's
do
a
change, or these constants, these fundamental things are not immutable. They do change.
no, the scaling of the space time you're dealing with changes, and therefore their effects on that scalar space time is merging together. It's not that the force and the way it interacts changes. It's just the dominion of space time you're dealing with gets so small that the delineation between the forces can't be gauged. It's kind of like, let me put it like this to you, right? Gravity doesn't change. It's just that if you get small enough, the effect of gravity is superseded by the strong, weak, and electromagnetic forces. And effectively, gravity isn't a force on that dominion, on that scale. That doesn't mean gravity has changed. It's still constant. So the same thing is happening here. It's just merely an argument of the scale at which you're dealing with this leads to the proposition that it would be unified functionally, not that the properties of electromagnetism have somehow changed.
Let's see. Do you have any questions for me?
Sure. So insofar as your beliefs about, like, if you had to describe the core properties of God, like, for example, what is the first necessary property of God from your point of view, even albeit you don't believe in it, what would it be?
I have no idea, because historically all kinds of different gods that all have different kinds of properties have existed. So if you're going, if you're going to invoke that there's only one such thing as God, and it is that which is the tri-omni whatever, it's like, okay, well, that's a pretty recent innovation. And if that's the God most people are talking about, then I'll go ahead and play along with that, and let's go from that starting point.
Okay. I just want to address the super chat. Somebody asked me, what religion am I?
They
not
wanted
very
to
religious.
clarify what denomination as well.
Yeah, I'm not super denominational. I'm not religious. I'm practically and functionally attempt to be a Christian, but insofar as, like, do I hard body ascribe to any religion? No, not really. So
Gotcha.
now, as far as you said,
Real
from
fast,
that point of view,
there
sure.
are a few super chats, so I'm just going to shoot through these real fast. All these
Yeah.
add a little bit of time, so you guys get plenty of time to cover these and then continue. But Vinova, thank you as well. He was asking the same thing. Nobody in Fire is super excited to see you, Eric. He's a fan of yours. Eric P, Prophet of Spanky, oh, fuck yeah. JC asks, I think this is for Chad, if infallibility implies self-knowing consciousness, can impersonal physical laws ever truly be called infallible?
If infallibility implies self-knowing consciousness, can impersonal physical laws ever be called infallible? Well, I think I'm trying to unpack the question. The assertion of physical laws being infallible is just an assertion of physics. It's not a demonstration. It's just like an axiomatic statement that this is the necessary thing to it. So that's where the infallibility of the physical laws comes from.
But what do you even mean by that? Do you just mean that the laws of physics can't be wrong? Because that just seems like a tautology that isn't very interesting.
Yeah, it's not very insightful. It's just an axiomatic statement that, like, again, like, the operation of an electron is always perfect. We never observe an electron, like, just bug out, basically. Kind of in lay terms is what that means. We've never observed an electron do anything other than be governed perfectly by the electromagnetic force. So it's kind of an assertion that going forward, like, even though retroactively we've observed that, the assertion is that in the future, this will also hold true. How can we know this? We just assert it to be the case. And it appears to be. I mean, as far as we've been alive, that seems to hold. And the first question, the first person I says, if infallibility implies self-knowing consciousness. Self-knowing consciousness in this context is kind of like anthropomorphizing the entity, right? Which is, I think, one of the largest issues that so many people have with religion and God and all this stuff, is because in antiquity they loved, oh boy, they loved to anthropomorphize God into like something that is human-like, can be talked to, etc., etc. This was they had a kink for this, hard body. And I think that that's, your question is somewhat remnant to many people who preach such a thing, because when you say self-knowing consciousness, you're implying something like how we know ourselves as being conscious. I would say our consciousness is nothing like God's consciousness. Our ability to know ourselves is nothing like God's ability to know himself. The assertion that God knows himself perfectly is merely because he is himself. The assertion is that if you take the stance that God is the primordial source from which everything emerges, it is the case that God would exist as himself perfectly. And in that state, it would be necessary that he would know himself perfectly as he is himself perfectly. So that's just how I understand it. So I don't know if I did justice to your question, truth be told, because I think that they are basically axiomatically asserting the same set of properties, that laws of physics are infallible and that God is infallible. How do you know this? It's necessary for both physics and for the theistic worldview. And that's why I say to you, if you draw a Venn diagram, it seems like, whoa, there's a lot of overlap there. There's a lot. I guess you can please answer that question. I think it's more than fair that you get some room to talk.
What am I seeking? I'm not seeking anybody. And what am I seeking?
I'm not sure who or what they're asking that about, so, but thank you for the super chat.
Yeah, I don't know. I mean, like, I could sit here and give some comment that's supposed to sound deep, like, well, I'm just searching for the truth or something like that. But like,
hell yeah, brother.
Like, whatever.
That's what I was going to say.
After you answer this, I got a question for you.
Yeah, I mean, unironically, I'm just seeking the truth, or as close as I can get to it.
Yeah.
So yeah.
Okay. So do you accept that Newtonian, like classical physics, it basically has been superseded? Like quantum mechanics told us that it is basically false. It's extremely accurate in when you're not moving very fast or at large scales, but it's actually kind of basically false.
Yeah, sure. There appears to be a very sharp delineation between quantum and classical physics. And obviously Newtonian is the most primordial of them, as it was just the most practical application without really
so in the spirit
any meaningful argument for gravity. Yeah, go ahead.
In the spirit of science, are you open to the idea that the current laws that we understand are open to revision?
To a degree. I think that we've really kind of hit a very hard wall insofar as our ability to investigate beyond this dominion, because we're using the smallest subatomic particles to test the smallest subatomic particles, and the things that we're generating from them exist for such absolutely immeasurably insignificant periods of time that the idea that we would ever conjecture some mechanism by which we could take those things and then test them seems highly improbable. Is there a possibility that one day we could do this? Yes. I don't think it's going to happen in my lifetime, and I don't think it's going to happen on this planet.
Far out. So do you think that God is falsifiable?
Certain propositions of God, of course they are. It just depends what you mean by the term God. What I'm purporting is I'm trying to define my term.
You on your terms.
In my terms, falsifiable. Sure. I mean, it would be falsifiable in the sense of like, could there be a coherent explanatory model wherein which there isn't something that at some point is irreducible, infallible, non-emergent, etc.? Yes, I guess you could falsify it in that sense. You could say, yeah, like here's a model where those properties don't exist, and it's a fully coherent explanation of what you observe around you.
Well, at the end there, you kind of started talking about the universe or physics or something, but I was just asking you about God. Like, is your concept of God, is that open to revision?
Um, I guess. I mean, have revised it many a times before I've gotten to the conclusion I hold today. And it could be the case that if I could speak to myself 20 years from today, maybe I'd have some other revisions that I'm not aware of today. Yeah, sure. But
Okay,
for example, could something as fundamental as God being non-emergent be revisable? No, that couldn't be the case. Like that's an ontologically necessary property that
okay, that was going
this
to be my
entity would
next
possess.
question. I was a little surprised by your first answer, but then I was going to ask you, okay, well, that is your idea about God being what you just said, revisable. So this is a little bit strange because you're kind of saying the reflection of the evidence that natural science points to God or whatever is that what is fundamental, as we understand in science, has those properties of God or whatever. But they actually don't. The science is open to revision and interpretation. And in some senses, you're saying God has that, but in other senses, you're not. So it seems like they don't actually share the same logical status.
Well, I'm saying to you that, for example, right, the notion that there is a constant in physics, I don't think that's a revisable concept. From any angle you will ever create a model, there will be some constant that is the bedrock of your model. Could that constant and its values be mutable? Sure, it's very possible.
Well, there could be
But
different
is the
universes with
notion
different properties.
sure? But a different universe with different properties would still have some constant respective to them.
Well,
So
yeah, but
that the
those
value
constants
of
would be
X.
but those constants would be different. I don't understand how that fits with a God that is immutable.
Well, I don't even believe in many universes. I think that this is such like a Rick and Morty like cop out argument. I
It's
think it's
the
so silly.
physicists arrived there because the math took them there. They didn't invoke it in order to try to explain away a problem that they were having. Nobody
They
had this
literally
idea
did.
until they read the math and realized, oh shit,
They
there might
literally did.
this might actually be a thing. It's kind of like black holes. People didn't just make up black holes because they were like, wouldn't it be like cool if black holes were a thing? Or the Big Bang. Nobody just thought one day, yeah, what if like it is all expanding? Those things where the black holes came out of the math decades before we ever confirmed that they exist. And Big Bang, yeah, we saw that the universe was expanding, and then we developed the Big Bang.
Well, also big black holes came out of an observational galactic center. That is a huge credence to why that argument came about. And to say that the many worlds interpretation came purely out of the math is the beginning of this conversation. I tried to explain to you how it came about. That the many worlds interpretation is a direct solution to the measurement problem. And so that's where it emerged from. It didn't emerge just like, oh, willy-nilly. It emerged as a solution to an
No.
observed phenomenon.
You're mixing up, and maybe I said the wrong thing, but multiverse and many worlds are not the same thing at all. One concerns the constants of the universe. One concerns quantum mechanics. So it might be my fault because you said many universes just a few minutes ago, and maybe I said many worlds, but I didn't mean to. Multiverse.
But many worlds is the multiverse.
No, they're completely
proposition.
different things.
So in many worlds, there isn't a plethora of universes.
No, that's
There
true,
is, right?
but multiverse and many worlds are completely different. They don't answer the same question, and they're not concerned with the same thing. Multiverse.
Well,
multiverse.
I don't know
is
what
the
the
idea,
multiverse concerns.
Multiverse is the idea that there can be many different pocket universes. It's still one shared infinite space-time, but there are different regions of this infinite universe where the constants have different values. That's multiverse.
Sure, but I like to think in the science that is at least somewhat demonstratable, like even an ounce of it is not even a fraction of a millimeter of that proposition as demonstratable. That's why I'm like,
Same-
okay,
same with God.
I too could conjecture an idea that has absolutely no grounding of any kind.
Sit, Uno reverse card. Same with God.
But this conversation is trying to elucidate the fact that that isn't the case, because once more, the proposition of God being immutable, infallible, non-causal is an assertion. The set of properties that encompasses is asserted in physics.
An assertion.
Furthermore,
if
there
we're having
are
a conversation about
assertions.
science, then I only care what can be what is either in evidence or can be like theoretically testable. Is your problem with multiverse that these other universes are outside the boundary of the observable universe, so they are just fun, like we can't go there? I mean, like maybe one day if we invent wormholes we could, but is you're just like, I don't care about that because it's completely outside the scope of what we can actually do practically, pragmatically, scientifically? Is that your specific gripe with multiverse? Because I wouldn't hold that against you.
What's one of the gripes of it is because, like,
Okay.
let's even assert we make a wormhole
Sure.
to go to said alternative universe. Wouldn't it just become a part of our universe now since we're there?
Well, it's technically one universe. It's just that in different regions outside the observable universe, perhaps the constants have different values.
So aren't we just equivocating on the term universe at that point? If we don't really
Not
mean other
really.
universes, we're just mean that there's one holistic macro set, and within that there's subsets. Well, what I mean by the term universe is the holistic macro set. And so if you're telling me I don't mean that by the word universe, I just mean that there's subsets within the macro set, then don't call it a universe, because the term universe very clearly outlines the most macro set that encompasses all subsets.
We often say universe when we really mean observable universe. People are a little bit lazy with the way they use words. That's just there. No, I'm not aware of anybody that doesn't think there's more universe. If I teleported you to the edge of the observable universe, I've never met anybody that doesn't think that there would still be more universe out there. I've just teleported you to a place where it's just it's just unobservable because of that's just
Yeah, I know, but when I
works.
speak universe, I mean not observable. I mean holistically. Like, sure, if we teleported to the absolute furthest edge of what is observable today, I don't think that there's just a blackness that just goes in forever. I think there's more of the same, right?
Yeah,
That's my proposition.
multiverse.
How more of the same? It could be, but that isn't a multiverse. That's just like
it
one
is,
universe.
though. Yeah, it is.
How? How is it? How is it a multiverse? It's the same universe. It's just like we don't observe that portion of it.
Because in an infinite universe, different regions, like the universe used to be, it's not really accurate to say the universe was smaller, but the observable universe had a smaller diameter in the past. There is absolutely no reason that you cannot invoke that in different regions of this infinite flat universe that inflation or big bangs or whatever didn't happen in different locations across that infinite universe. And so the constants may be different in those different regions.
Notice how you yourself, really even when trying to explain this idea, you keep on flip-flopping between universe, observable universe. What you mean by this? It sounds like a very strong equivocation of terms.
It's not really that difficult. We have the universe is flat topology, as much as we can tell. It seems to literally just go on for infinity. We know there's an edge to the observable universe. The idea that there's more universe out there, that's even you agree that would be the case. There's really nothing you can invoke that says the universe beyond our observable universe must absolutely have the same constants tuned to what we see here.
Except that is the fundamental axiomatic assertion of physics.
In like our observable universe,
because
we only
I
exist
disagree
in our
with that.
observable universe. There is absolutely no case you can make that in a different in a different part of the universe, in a different bubble, in a different observable universe across an infinite universe, that the constants could not be different. So anyways,
I know, but you're invoking some sort of distance, as if there's some gradient to distance. Because like I'll take your argument.
You didn't really understand what the concept even was, but
I got your concept very well. I understand perfectly what you said.
No, you didn't know the difference between multiverse and many worlds even. And then when I explain it to you,
they both invoke multitude of universes.
But in in completely different
It's
ways.
just
for
one is
completely
grounded
different
in a
reasons.
scientific.
No, dude, the many worlds interpretation of
lagging.
quantum
I think I'm
mechanics
lagging.
doesn't say that in different observable universes, you observe the nature or pattern of the wave function in like all of its perturbations manifest in some way. It doesn't really collapse, but all the possible different types of measurements can be made, but it just happens in different observable universes. That's not it's not at all the same thing. But anyways, we're getting like way far separated from why I was even asking this.
Yeah, I don't want to hit below the belt and start doing this. You didn't even know this, because I could have done that 20 times on you. So please, let's deviate from that. Furthermore, when you're speaking of universes in this context, once you say that there could be some other set of laws beyond what we observe, what is stopping then from me saying, okay, well, actually, that gradient doesn't occur outside of our galaxy? That gradient is already happening at the Andromeda galaxy. And so the explanation of a
observe the Andromeda
quasar, the explanation of an SN1A standard candle, a quasar in the Andromeda galaxy, to which we use to calibrate redshift and thereby be able to tell the distance between us, that I would argue to you that the physics that governs a quasar in the Andromeda galaxy is actually different than the physics here. What's stopping me from just taking that position? Why does this new set of physics why is it beyond the observation
because
threshold?
of the physics that make that quasar in Andromeda are fundamentally different than they are here, then I don't think the observations would hold. I mean, there are other observations about Andromeda that we can make here that match the physics that we know here on Earth. Like for example, you can look at it at the Andromeda galaxy and you can see, well, it's based on the observable matter. It's spinning too fast to be able to hold all that matter together. So yeah, there's a dark matter halo. We don't understand what dark matter is yet, but that kind of observation you can make with Andromeda and any other galaxy that you can look at. So
then it just hinders the scope of the application of
hold
physics.
consistent across the different galaxies, but also, sorry, what?
I'm saying to you, then the practical application of physics then gets hard stipend, because you're saying then the physical laws and the constants and the et cetera, the governing principles are different in every galaxy. Why are we limiting that the difference in their actual function is somehow beyond the visible gradient? That because we cannot see beyond a certain threshold, then beyond that threshold is where the different laws exist. Why can't I take your argument and then just say the different laws actually start at the Andromeda galaxy?
Yeah, so it would actually be pretty simple. We can demonstrate that wherever you are and wherever I am, the laws of physics are the same, right?
Mm-hmm.
Why is that?
We can test that. Like, I can come over to your house and we can both drop an apple.
No. Not why can we test it? Why are they the same?
Because we assert that there's a homogeneous uniformity to the laws of physics.
Right. So our understanding of those constants and their relationship is actually fundamental to. It's fundamental to. I would say this is going to come out kind of clunky. I don't know how to say it in the correct way because again, I'm not a physicist. But those constants or whatever are actually fundamental toward our understanding of like the Big Bang itself, right? So whatever is within this observable universe is a result of all those constants that make physics the same where you are versus where I am. So to invoke that it's different in a different place in the observable universe completely betrays why it's the same between you and I here. But we've been talking about this for like 20 minutes, and but I haven't actually made the point I was going to make. So, can I even remember? Oh, so the reason you think that, like, I don't know if you think that the multiverse just is false, or if you just think I don't bother thinking about that because it's a different observable universe. So what's the use of it? That's fine. It's in more a way, the latter. I kind of agree with that. Say that again.
I was just saying it's more the latter, that I don't see any practical utility in it.
Sure. Where is God?
In what, the multiverse?
I'm asking you the question.
Well, the where is he
Yeah.
is a spatial question, right? It's a temporal spatial question of an atemporal aspatial agent. I don't
Okay.
really know how to answer. It'd be asking like, what is the flavor of purple? I don't think purple has a flavor. It does categorically does not possess a flavor. Like God does not categorically possess a position.
Sure. So what's to stop?
And real fast, there's
Yeah.
a comment that's been on the screen. I'd like to get it off real fast. Is that okay if I do that real fast?
Mhm.
Sure.
Cool. So Mr. Kiki was responding to a logic's axioms, the no deity, relabeling them God as circular, redundant, untestable, and inflates necessity into theology without gain. Thank you for the super chat.
Logic's axioms need no deity. I get you. So you're saying like the law of identity doesn't need a deity. Um. Well, the law of identity, as I understand it, is rooted in the fact that God is Himself. The assertion that God is Himself, therefore, because He is Himself, that is what identity is, and that is why that principle is not only insightful into information, insightful into knowledge, but it seems to be uniformly used in every single school of thought, mathematics, physics, you name it. It's not something that can be violated. And why it can't be violated is argued to be in virtue of God's nature. Since God is infallible, His nature would therefore be infallible. And since the derivation of logic is simply the assertion that God is Himself, that principle would also be equally infallible. In a non theistic worldview, while, I mean, crudely speaking, I guess maybe you could argue and conceive of some form of logic being, then you are run into the problem of why then is this tool that you derived insightful into anything? Why are you using it to garner knowledge? Why is it something that gives you insight into truth? What gives that principle? And that I don't think can be grounded in an atheist worldview. It's just like, oh, just it is because it is. But in a theist worldview, it's very clearly grounded that the reason logic gives you insight into information and knowledge is because it is a part of God's nature, and God's nature encompasses all knowledge.
Isn't God's nature just is what it is?
Is what it is. I mean, can't you say that about anything? Couldn't I just say you are you that you are? Couldn't I say that this laptop is that it is? I mean, like, if you can apply a statement to everything, that statement has no value. So if it can be applied equilaterally across any single thing you can possibly conjecture, I don't think that's a critique of anything.
I don't even know what that meant. But if you're saying no, you cannot say that the I'm not interested in a discussion of logic. But if you cannot say that the fundamentals of nature, like eventually, like why does this have that property? Because of this. Why do protons have a positive charge? Because they have two up and one down quark, or the other way around. I don't remember how it is. Okay, but what about quarks?
That's
Quarks
correct.
are fundamental. So there's nothing else there with respect to the quark. Well, I mean, yeah, with respect to the quarks. Well, you can't just say that quarks just are. Well, God just is. So I don't understand why violating the principle of parsimony is better, and then just saying, well, yes, the quarks, but also God, and then we stop there.
Mm-hmm. Well, it's because the assertion about quarks is that first and foremost they're emergent. We can literally manufacture them. They're also testable, repeatable, measurable entities that are temporally constrained, that cannot be applied to God. Furthermore, they're governed by a principle that is external to themselves, which is, again, another asymmetry between God and a quark. So there are many asymmetries between the assertion of that quarks are fundamental and they are just because they are, and the assertion that God is because He is. And these are just the three immediately off the cup asymmetries between these propositions. So they're just not the same thing.
You said that quarks depend on, they emerge from other what?
Yeah, so the standard model asserts spin, mass, and charge as the three fundamental immutable properties of any subatomic particle in the standard model. Quarks possessing this. And so there are higher principles that govern that which we describe a quark. So to say that quarks are somehow fundamental
God
wouldn't
has
even be
that, though.
correct in quantum field theory, because in quantum field theory, the assertion is that the field is the most fundamental thing, and the field doesn't have any measurable anything. Like there is no spin of a mass of a field. There's no mass of a field. They lack any of these properties. It is from the field that these properties emerge. So to assert that quarks are somehow fundamental wouldn't even be correct in the stance of physics. They would never take that stance.
Well, it's called the fundamental, the standard. No, it's not called the. Why did I say that? But no,
Standard
they
model.
do say that quarks are fundamental.
As in they're irreducible. As in, like, for example, like correctly you pointed out, a proton is called baryonic matter.
Yeah, they're not made
Baryonic
of
matter
anything
encompasses
small,
protons and neutrons. A proton is 2 up quarks, 1 down quark. So the position that a proton is fundamental, it isn't. It's reducible to quarks. The assertion that quarks
Yes.
can somehow be subdivided into something further, while theoretically may be possible. I argue that, again, we'll never achieve this because of the scale of what we're dealing with. And that even if we subdivide a quark, then the thing we subdivided it into, we just make the assertion that that thing is now irreducible. So like at any point in time, you ultimately get to a point where no matter what lens you investigate the natural sciences through, you ultimately reach a point of irreducibility. And that was the argument of the atom. Before any telescope, microscope, any of this was conjectured, they just philosophized to the notion that if you continue to subdivide, ultimately you would come to something indivisible. And no matter what angle you come at it from, that is what we have. And we can't get beyond that. And we never will.
Doesn't your God have 3 primary properties?
Which I've been repeating. Yeah, that's my assertion.
Well, then your God is divisible.
No, not divisible. No, brother. It's these properties are commingled with each other. So, for example, it's equally. I try and draw an analogy to people with this, right? It's equally impossible to talk about a monopole. There are no monopoles that anyone has ever discovered in physics. While they argue there may be one, nothing has yielded any such experimental demonstration. When you speak of positive, you already inadvertently only speak of that in it's a negation, that there is a negative. That positive only can be understood in its negation. So I'm saying in this same exact concept, once you understand that the property of God is such that he is non-contingent, non-emergent, non-causal, it is therefore necessary that he would equally be immutable and infallible. It's not that they're delineated from each other. It's kind of like logic. Once you assert the law of identity, you immediately assert the law of non-contradiction. It's immediately follows that. It's not separate from it. It's just its negation. It's its necessary negation. And the same exact thing is true here, that if it is non-contingent, it is therefore necessarily infallible and immutable. Also, there was someone who wrote a super chat and it went away. So, like, I don't know. I want to make sure that we're kind of, because I don't see anyone posting.
I'll put it back up. I was going to ask it after. I just was leaving it on the screen.
Yeah, no
Why
problem.
is Chad wearing a very V neck shirt if he's going to cover his chesticles with hair?
That's just how
it was off topic.
My bad.
But...
yeah, sure. It's just, you'd catch me in the street like this, bro. Probably even more crazy than this. So that's just who I am, bro.
Chad, I cannot think of any other question that I would ask. You can ask me whatever you want.
Yeah, sure. I mean, I appreciate you for even asking questions in the first place. I guess my position to you is more of a. This may sound a bit kind of like a callous question. Don't take it as such. I find that the question of God is the question of the world around us, right? And the world around us is the investigation of natural sciences. So if I were, for example, right now speaking to you about multivariable differential equations, and you made some proposition about the non-existence of said thing, a multivariable differential equation. And I would ask you, well, hold on, do you like know your period, like times table? And you were like, well, you know, I kind of learned about my times table. I read about it and then I forgot about it. And I'd be like, do you genuinely think you have like a credible opinion about multivariable differential equations? It would sound to me like it perhaps is rooted in ignorance. And so I pose the same question to everyone here, and why I even had this topic in the first place is it seems to me slightly of ignorance to hold the position of certainty on God without having a in-depth understanding of the natural sciences, and in this case in particular physics. And so I wonder, why is it that you hold a certainty, seeming the conversation we had, I take you to be certain that God isn't real. How is it that you've derived this certainty while simultaneously having kind of a much more shallow understanding of the natural sciences than me?
I think you should talk to an actual physicist. I don't think that you would maintain your confidence if you did that. God is literally a contradiction, especially the God of the Bible. So, some sort of God might exist. I'm an agnostic atheist, but you can't have these three omni properties at the same time. It's literally not possible. And the God of the Bible certainly is not any of those things. He changes his mind. He lies. He loses battles to other gods. Other gods exist. He doesn't. There are things he doesn't know. So he's not all powerful. He's not, and he sure as hell isn't like all good. And he's not all knowing either.
No, I'll extend an olive branch to you there. I agree that in the sense of like, if you were to take the most literal interpretation of the Old Testament, New Testament, biblical God, yeah, that's pretty hard to ground in really anything. And I also equally kind of, I don't say make fun of these people, but I try to be like, you know, insightful to them and be like, hey man, that doesn't all check out, right? However, more broadly speaking, so, for example, some of the arguments made in the Zohar are parroted by famous physicists. And there's even a clip of this dude, Michio Kaku, where he's in a conversation call and he points this out clearly, that like the parallels between Big Bang cosmology and the argument made in the Zohar and the properties attributed to Ein Sof, if anyone wants to Google this, EINSOF, it mirrors exactly the argument we make for the singularity at the beginning of the Big Bang. And that it being dimensionless, colorless, without any property you could attribute to it, completely singular and homogeneous. These properties are well outlined in a text that predates the argument of any physical Big Bang, going back well over 1,000 years. And so I say to you that a lot of people who argue against theists and against God do it in a way where they attack religion. And it's like, okay, I get religion it's a cultural thing. You know, and we can see that very clearly in the countless denominations of Christianity, right? But all and every one of this denomination of Christianity or Islam and Hinduism, Judaism, they all assert some fundamental properties. Like I said, the non-emergence of God, his infallibility, his immutability. These properties are ubiquitously asserted. And I do, though, grant you that in the New and Old Testament, these things, insofar as the, you know, what even seem like later additions and sort of different scholars' opinions on this, different books coalesced together, some of these narratives that they present about God, you know, being like, I don't remember exactly the story in the Old Testament, but it's like, I'll kill 1,000. And then, no, he changes his mind, I'll kill 100. Oh, no, I'll kill 10. It's like, yeah, okay, well, what do you mean? That's like a clear example of him supposedly changing his mind, right? So in that sense, I agree with you. But in the more like 50,000 foot level top down perspective, I think that the ideas purported therein still stand to this day and are even substantiated by physics in many cases in regards to, again, let there be light being the first argument, the proposition that God delineated one from the other, as his first act, like the heavens and the earth, and that the fundamental assertion of every physical model is exactly that they first assert that there's some delineation between this and the other. And once there is a gradient, then you can say things emerge out of that gradient. But the gradient itself is not emergent. It's not like a physical thing. So in that sort of more holistic worldview, I think that their proposition still stands.
Okay, so Chad, are you a physicist?
Mm-hmm. No, I would have loved to have been one. I think I would have been a pretty decent physicist, but I grew up pretty wicked life, and that shit didn't work out.
Are you aware that most physicists are atheists?
I think that they are non-religious, but are most physicists in opposition to a more holistic idea of God, again, being some immutable non-physical entity that governs the principles of the universe? No, that there's a slightly over 50% majority, not by much, but that's the studies I've seen.
Slightly over 50% of physicists what?
They believe in some like higher power is what kind of I believe the Pew Research science, like the survey asked, and that's what they concluded. But as far as are they like religious? Yeah, the majority of them are not religious.
I've seen single digit results for physicists that actually believe in a personal God. A higher power could mean anything. It wouldn't be God. So I bring this up because you said, well, if I actually understood this, then I wouldn't be so like dismissive of God or whatever. The data bears out exactly the opposite of that.
Well, notice that I never once talked about a personal God. Did I ever once invoke anything of that nature? Did I ever? A matter of fact, I preface this conversation by saying I would like to point out the fact that many properties attributed to God, like being omnibenevolent, having a will, even the fact that you can pray to him and he'll listen to you, aka a personal God, are dubious propositions that are solely based on faith.
That's fine. I think it would be really foolish to assert that physicists overall maintain beliefs about any kind of God at a greater percentage than the general population. That I don't have a specific poll that generalizes it out to its extreme like that, but I think you'd be completely out of your mind to assert that. So,
well, many of the great physicists
it still holds true that like your claim that like if I studied this, but if I was more educated on this, then whatever, that's just not the case based on what we.
No. I'm not saying that you would like simultaneously. I'm not saying that if you somehow educated yourself to my level, then you would immediately see the world as I do. No, I'm not saying that. I'm merely pointing out the fact that sounds to me slightly of ignorance to hold an opinion on this while simultaneously not having an in-depth understanding of physics, because it's equally
people that have an in-depth understanding of it that feel the same way I do about God, at least.
A personal God, a religious personal God. Yes, they do. I feel the same way. Now, does that mean that they feel that about there is something that is rooting the constants, the uniformity, the immutability of these laws? No, they don't. There are many physicists who say that there could be, and very much so is that the case. Again, some of the greatest physicists of all time, Einstein was a pantheist. Werner Heisenberg clearly was a theist. So like there are many people I can list off to you that were theists, died theists, while perhaps not being religious. Like I myself, I see value in Christianity. He believed he was a pantheist. Yes, absolutely.
Why do you say that?
He was quoted countless times as literally telling people he's a pantheist.
Can you give one example?
You can look it up.
I've never ever heard that before.
Yeah, it's just the same explanation I'm giving you. Crudely speaking, he made the same argument. He said that there appears to be a uniformity that needs to be grounded in something, and he argued that the universe.
It sounds like you're interpreting Albert Einstein's words.
No, I mean, type it into Google. You think I'm lying to you? Your computer's right in front of you. Is Albert Einstein a pantheist? Click enter. Read about it. Now, pantheism is a
While he's Googling that, there are
yeah.
2 super chats. I'm just going to touch on those real quick. Nobody
Sure.
in Fire was commenting on your necessary claim. I put necessary into the definition, therefore it is. And then, thank you so much. And then JC was asking a question. If God is by nature indivisible and immutable, how can something you admit be further broken down and theory be the same kind of ultimate being?
If God by nature is indivisible and immutable, how can something you admit can be further broken down in theory be the same as of an ultimate being? Well, I'm not saying it's the same. So I'm saying to you, for example, Einstein made that proposition. A pantheist is the argument that the universe is God. And like, if you could look at the singularity somehow, that the singularity would be sharing in its properties with God, that it's not causal. It doesn't come from anywhere. It's, non-contingent. And in virtue of it being itself, it would be perfect, et cetera, et cetera. That's his point of view, summarized in a nutshell. My position is that the singularity in the physical world is not God, that God is distinct from the physical world. And so I would never say that something like that could be further broken down, like a quark, let's say, if we could break down a quark and get to something even more fundamental, that more fundamental thing would therefore be God. My assertion is that God is ontologically distinct from the physical world, and that the physical world, even in its summation, and if you could take the entire observable and unobservable universe and you could crunch it together into one point, that thing, it was not God. That's God's creation. God is distinct from his creation. These things are separate. So that's what I mean is in a more holistic sense, like if you encompass pantheism, if you encompass a higher being, a higher power, like some agent that is responsible causally for everything around us, even though he may not ever speak to us, might not even give a fuck about our existence, or that he never even conceived of our existence in the first place. If you encompass all of these under one umbrella, the majority of physicists fall under that umbrella. Now, if you are to delineate the umbrella into a more personal God,
what umbrella?
The broader umbrella of pantheism, a higher power, some agent that constitutes the causal nature, the argument of the cabal. If you take this broader umbrella of the arguments of God, the majority of physicists, slightly above 50%, fall under that umbrella. Now, if you were to say more particularly a Christian personal God, then yes, you're totally correct. A small minority of physicists believe that.
Oh boy, no, I lost track. I have a lot of studies pulled up here, but no, the whatever. Maybe I can find it, but I do not think that the over 50% of did you say physicists or scientists?
I think the Pew study I saw, if my brain is doing me justice, is regarding physicists. And it's a Pew study. Like, if you're looking for one, that's the only one I know that's quote unquote credible, that people are like, consider non-biased in some sense.
And
this is a little far away from me. You want to read that super chat? This guy really put in some money for you, brother. Shouts out to you.
And thank you so much for the super chat. Nobody on Fire. He says Einstein. He's quoting Einstein. The word God is for me nothing more than the expression and product of human weaknesses. The Bible is a collection of honorable but still primitive legends, which are nevertheless pretty childish.
I don't know if he's directly quoted as saying this, but I'll take your word as he is. The second part of that sentence, in vain, while perhaps a little bit overstepping, I agree with him. Generally speaking, many of the sentiments therein are just stories, parables to try and portray something, and it's even dubious and questionable whether the events described therein ever occurred. So I would agree with that. As an expression of human weakness, I don't agree with that. I think that it's a expression of the inevitability of any approach. Whether you approach it from a metaphysical, purely philosophical, strictly natural science point of view, at some point in time, your worldview breaks down into something irreducible. And that irreducibility, necessity, non causal nature of that proposition is what is argued to be in virtue of God's nature, since God possesses these properties. Now, I would agree with you, the sentiment of human weakness in regards to, like, oh, I get on my knees and I pray because, I have cancer or something like this. Sure, in a sense, that's grounded in human weakness and sort of like our desire to, I don't know, be better than we are or something like this. But I think he's more addressing like the very kind of religious sentiment, not the one that I'm trying to address here or explain.
So there's the Pew study. It's from 2014, and it assesses the general public and scientists and their beliefs in God. And there was no majority. There was a plurality, but for scientists, a third of them believe in God. 18% of them don't believe in God, but believe in some sort of higher power. And 41%
Sure.
of them don't believe in either. That was the majority. And then 7% just had either didn't know or didn't give an answer.
But is it in this case the majority of the scientists in this case? I guess the study is more leaning towards. Isn't it the case that the higher power and like hard theist argument, doesn't that make up more than 50%?
In this case, it's 51%, but
Yeah.
that higher power, but the higher power specifically says don't believe in God, but do believe in some sort of higher power. So you'd have to tell
Sure.
them.
And what
no,
I
you
think what
actually
they
do
mean
believe
by
in God,
like,
which
yeah, what I think they
don't
mean
think
by
that's
God
really
in this
fair.
context is that personal relationship, that like Christian, et cetera, et cetera. So like they say
It
that there
doesn't
is no
specify
personal
personal God
relationship.
or anything like that.
Okay, well, I think I'm somewhat vindicated in saying that it's a small majority, above 50%. It's 51. That's a higher power and or God.
Yeah,
So
but a third of them don't believe in God.
yeah, that's fine. But 51% of them believe in God and a higher power. Which again is, like I said to you, if you took the broadest umbrella of just the Kabbalistic argument that there's some causal agent that is not even personally related to you, but is a necessary causal agent, they would fall into the higher power category,
Well,
even like
that's
spiritually
fine, but
speaking
it's
or
not
whatever.
God for many of them. Do you have any other questions
For
for me? I don't really have any. Like I said earlier, I don't really have any more.
as far as for you, well, you're not making a positive claim, right? You're kind of like trying to knock my little straw man down. As
Well,
far as for
you're
you,
in the affirmative. I just don't. I mean, it would have been. I don't know. I mean, I feel like we didn't talk about the topic really at all. I feel like everything was just kind of like very meta.
I
And there was
tried to
quite
get
a
into
lot
the
of this
topic, but
esoteric stuff. But I laid out in
yeah,
my opening statement, science is methodological and predicated on naturalism. God is not supernatural. There's no such thing as like empirics of the supernatural because we have no idea how the supernatural works. And your whole argument was just that, well, it's fundamental and axiomatic. And I said this
uh-huh.
earlier, but my whole thing what is if you're going to take an affirmative claim on the topic for this debate, then that says to me that you are arguing for something that is in evidence. And if you can't present that and instead it's all just this philosophical talk, then I mean, whatever you can. I don't know really what to. I tried to ask some questions, but like I said, I pretty much ran out of stuff. An
Yeah,
actual
but the
physicist
philosophical
would
talk
do better
is
with your
due.
claims there. So, like, if you have any
Yeah,
questions for me, I'm happy to answer them.
the philosophical talk is due to the irreducibility of the propositions made therein, and also
I mean, that's just
it's
a
a
claim.
bit of a okay. It's the notion, for example. Are you familiar with Rene Descartes' work, or the Ercogito Sum?
I mean, a little bit.
Sure.
He just that
For
was the only thing
example,
he
do
couldn't
you
doubt.
know?
That was the point.
Right. But for example, are you familiar with the quote unquote proof he provided for his own existence?
That no matter what, no matter what, he couldn't doubt that he is thinking. So there is this thinking thing, and that certainly exists. Now,
And is that a proof?
no, it's a presupposition.
Okay. So
Well,
if you can
it's kind of
understand,
weird.
yeah, like let me give me a second. If you can understand that the burden of proof can't even be met for something as egregiously obvious as the fact that you are having an experience, that you could not propose a scientific experiment, repeatable, testable. You could not provide a sound syllogism that is not axiomatic and circular in nature to something as belligerently obvious as the fact that you're having an experience. How then can you levy a burden of proof for God? You can't even meet that burden of proof for the fact that you exist to yourself, not even to me, just to yourself.
Are you telling me that I can't prove that I exist, but you can because you believe in God or
No,
something?
no, I'm saying to you that no one can. That providing a sound
Then why are we
contingent
here talking
relationship.
about God? It sounds like you just said that we both wasted.
Well,
our
I'm just
time.
demonstrating to you the limitations of a proof. So to then levy
Why?
a
Why are you
proof
doing
and say
this?
to me that you need to meet this exorbitant burden of proof, I'm saying to you, well, before we try to meet that exorbitant burden of proof for an omniscient, omnipotent, non-causal agent, let's first see if we can even meet that burden of proof for yourself and if you exist to yourself. And if you can't do that for yourself, how are you then asking to levy that burden of proof for something so far beyond anything we can even conceptualize in a practical sense? It seems a little absurd to me.
I don't know what you're even talking about. I mean, I don't have a syllogism for you that I exist. Maybe I could come up with one, but I didn't prepare one ahead of time. I can't doubt that I exist. That was what Descartes was saying, and I guess I agree with him with respect to that. It is fairly low resolution. It doesn't prove that you're not a brain in a vat, but that doesn't to me. That doesn't matter because okay, I'm a brain in a vat imagining this. I still think and I still am. I don't know I'm a brain in a vat, but I still think and am, right? So like I said, I don't have a syllogism for that. I don't really have the view that things that are in evidence, like things that are self-evident, like require syllogisms. I have a tape measure in my hand. Can you put that into a logical syllogism? No, I don't really think that that's super necessary. So, but I have no idea why
I would
we're
agree.
talking about this right now.
I'm saying to you, like, in essence, you're asking me to provide you a proof for God, right?
No,
Well, he made
evidence.
a good point there. So you should be tying these topics or these points you're making back into the topic, especially if it's like logic or argumentation, something like that. It should be tied back into the topic of do the natural sciences.
I'm not an analytical syllogistic Phil bro. I'm a science slut. So I don't need like you don't need to couch it in syllogisms if you want.
Well,
like
I'm not
said,
sure what to
based
do
on taking the
because in
affirmative
one
of the
sense, you're
topic,
asking me to ground this in science. And I'm like, okay.
you think
And I started
that's
talking
your
about,
belief, though. You took the affirmative.
but hold on for a second. You asked me to do that. And I started, quote unquote, gibberating about physics. And you're like, I'm not a physicist. You should save these arguments for a physicist. So then I'm like, okay, that's what I thought I was going to do here. I thought I was going to talk to someone who's at least somewhat educated or willing to have a conversation about the intricacies of physics, because in the details lies this, not in the malaise, like Rick and Morty opinion of like what I think and read in some like pop news article. In the actual details, you told me multiple times you don't want to discuss the details. You're not formally educated to the details, and you don't want to have. So I can't really tie it back to that because my argument is centered primarily in the details of it.
So your argument that
I've
natural sciences point to God is because of what we know about physics, like fundamental physics.
Yes, it's in the details of the models of physics and any model you can discuss. And I've given you many models that we can discuss and talk about, but you've kind of been like, I don't want to do this. So I've tried to be credible towards the line of conversation to where you want to steer it. But originally, my proposition is in respect to what Werner Heisenberg said, is that for the third time or fifth, or I don't know how many
He
times I'm
never
repeating
said
this.
that.
It's a quote directly from him, dude.
It's
Maybe
it's a quote from an author, and there's no source for the quote.
okay. Well, perhaps I wouldn't put it past him saying this, but
Okay.
either let's just grant completely he never said such a thing. Okay, that this is purely conjecture of some author.
What would that even
Fine,
prove,
no problem.
though? That Werner
It's not
Heisenberg
proving.
had an opinion? I mean, there were
It's
Nazi
reflecting my
Nobel-winning
sentiment.
physicists too. I don't have to take their beliefs. I don't have to believe that. Therefore, those ideas probably are true too. I don't have to do that.
Yeah, no, you don't have to at all. I mean, you can believe whatever you want. Nobody's forcing you to change your mind here. I'm just saying that my beliefs are grounded in my understanding of physics. And once I had gotten a thorough enough understanding, this revelation became evidently clear to me, one I could not ignore. And it came not because of, me watching some like Veritasium videos or like, going on YouTube. This came from well over a decade and spending countless hours investigating these ideas and the propositions made therein.
Sure.
And that's what I was looking to speak on. But I'm not trying to be, arrogant and kind of like steal the conversation. So if you aren't someone who can respond to me in a way that you feel is, coherent, then I'm not going to just gibberate to you these propositions that again are like going to sound perhaps fallacious or ungrounded, because to ground them takes a long time. It's like I didn't come about this knowledge of physics in like a day. This is a decade plus of me like genuinely investigating this topic. And so I'm trying to take my ideas and kind of spin them in a more like a generalized holistic perspective. And you guys are critiquing me for that, while simultaneously telling me that I'm not being direct enough.
I mean, we could just like, I don't know, rehash some old stuff, I guess. But so the only one of God's properties that we really talked about that you think is embedded in physics is God's infallibility. And it seems that we arrived at there are fundamental like laws of physics, laws of nature, whatever, which are true. And that's what it means for them to be infallible. I mean, I said that's not very interesting, and you said, yeah, it's not very interesting, and maybe it's because of the way I put it or whatever. But God is all powerful. Tell me where that is in physics.
All logically possible things that could be actualized, he can actualize. All powerful in physics is once more the argument that the four laws of physics encompass all that we observe and interface with. So quite literally, they would be asserted to be the exhaustive list of all of the powers of the universe and how we understand them, how we can manipulate them.
In what sense does that make them all powerful? Like if I argued to you that my phone is infinite because my phone encompasses all that which is the phone, there's nothing else that is phone that is not contained within the phone. That's not infinite. And so when you say that the four fundamental forces or whatever, and like physicists, a lot of physicists get really annoyed when you call gravity a force, but whatever. To say that all that we can study and observe in the universe is those things, therefore they're all powerful. That doesn't seem like much of a statement.
Okay, so I'm gonna try this one more time, and let me know where you're not understanding what I'm saying.
No,
the laws of physics are emergent.
I'm asking you to explain to me how that is an explanation of something that is all powerful.
Okay.
Because
that's not.
Let me. Mm-hmm. I know I'm interrupting, but I think I found a more instructive. Does the universe have limitations?
I mean, they would be governed by the laws of physics. Yeah, it seems that like something that would be not physically possible would be a limitation.
Okay, but God doesn't have limitations. So these are not all powerful in the
It's the
same sense at
exact
all.
same limitation. The limitation for God is that he can actualize all logically possible things. Things that are illogical are impossible. Things that are aphysical are impossible. It's not a limitation. It's saying that the thing you're describing isn't a thing. It cannot be actualized.
You don't think
It's
that
not a
the universe could
limitation.
possibly be some other way other than the way it is?
Theoretically, sure, it could be, but the way it is and the way it
Then the
is
way it is,
now could not.
it can't be all powerful. It doesn't encompass all of those things.
Nobody. So I'm not
Unless you believe in
saying the.
multiverse.
I am not saying the universe is God. You are
I
trying to
know that.
strawman us if I
No, I'm
am.
not.
So I'm not saying that. So let's not say
Nope.
that the laws of
You're
physics are
saying
God.
that God's nature and the fundamental aspects of physics are identical. They share a logical structure or something like that.
And what
I
is
don't
the
think that they
fundamental
do.
aspect of physics?
I can't remember the example that we went over earlier. What was that example where there was a breakdown where it's like, no, it was something about what the hell was that? I don't remember. I'll try to think of it. But I think we have an example of that here too.
Sure, but what are the fundamental concepts? Like, so you're kind of dealing with the derivation, that being strong, weak, electromagnetic, and gravity, right? You're dealing with the derivation. I'm saying to you, the fundamental of that derivation shares a property with God, not the derivation. And you're equivocating on the derivation and that which is fundamental to make the derivation. I'm saying to you, such that you can even derive electromagnetism, you must assume a gradient, and that the gradient
I have no
is
idea what that
immutable,
means.
infallible.
What on earth
Okay,
is a gradient? I assume a gradient. What does that mean?
right. Okay, so let me explain to you in physics, right? There's an inflationary model dealing with quantum fluctuations, and that these quantum fluctuations at one point in time decohered, and at some point in time led to the expansion of space and everything thereafter. The argument that there could be a fluctuation assumes necessarily that there is a gradient upon which something can fluctuate. Do you understand what a fluctuation is fundamentally?
It could mean a lot of different things. A fluctuation means the values
Does it not
change.
mean, does it not mean, correct? It means a delta, correct? A change. How
Yeah, I
could there
guess a
be a
fluctuation changes
change?
over. If something fluctuates, it changes over time. Yeah.
So if it
Does God change over
changes,
time?
no, that's not what I'm saying to you. I'm saying to you, for something to change in physics, for there to be some fluctuation that could occur, the argument in the model is that there's a necessary non-derivative, immutable, infallible gradient upon which this occurs. Do you here? I'll do you a
An
favor.
infallible
I'll
gradient
yeah.
is just such a nothingness
Can
phrase.
I read to you a excerpt? I've screenshotted this a long time ago because I wanted to like ground this in ChatGPT and whatnot, right? And I wanted to see if ChatGPT can possibly explain this in a more holistic fashion. So grant me a minute and a half to read you this paragraph, and this comes directly from ChatGPT. Okay. If you peel back every layer, general relativity, inflation, bounce models, wave function of the universe, you always find that there's something being assumed rather than derived in virtually all mainstream models. You assume some version of quantum mechanics, whether it be superposition, uncertainty, Hilbert spaces, amplitudes. You assume some kind of configuration space, all possible geometries, or pre-geometric structures like spin networks or strings. You assume a dynamic rule, the Wheeler-DeWitt equation, path integral, loop quantizations. It's telling you that the wave function, how the wave function behaves. Those assumptions act as your immutable, non-causal backdrop. They're not caused by anything inside the universe, and they're not derived from a deeper time evolution. They're the rules of the game. Everything else, space-time, matter, fluctuations, events, arise given those rules. Does that give you any more insight into what I'm trying to say?
Yeah, kind of. Those are just starting points, but they're revisable. I mean, in Newtonian gravity, you can just say that it's the mass of the object and the distance between them, nothing more. And you can do really accurate and incredible science that way. But that's actually revisable. You can go to general relativity, and it explains it in a completely different way with non-Euclidean space-time instead.
Well, can you then provide me a single model in physics that does not assert some non-causal backdrop to then proceed to derive everything from it?
I don't
And
know.
guess
I don't
what
know
you
what
get?
you mean. Why
You
it would have to
can't.
have a non-causal backdrop? You start. There are axioms that we have in science. So, for example, in like class, it's not really classical mechanics, but well, maybe it is. I don't know. But like Newtonian gravity, you don't assume any further underlying structure. You take the masses and the radii, and you can do all the calculations. You don't
Yes, but
assume
we're dealing
you
with
don't
models,
assume anything
brother.
else.
We are dealing with models. We're dealing with models that are dealing with the origin of the universe. We're not dealing with
No, I'm
models
not.
that try to, within a margin of error, accurately predict. Yes, they are. Every single one of these models is dealing with the origin of the universe. Every one of them.
You
That's
asked
what the
me
topic
to
is all
come
about.
up with a
When you speak of
scientific
God,
model.
you're speaking of the origins.
No, I'm not. When I talk about Newtonian
I thought you.
gravity, I'm not
I thought you
doing
understood that.
What?
I thought you understood. I thought it was very clearly apparent that the conversation of God is obviously a conversation about the origin of the universe, since God is
That's
argued
cute.
to be
You
the
asked
causal
me to
agent
give you an
that
example
led
of
to
a
this.
scientific model that doesn't invoke like some sort of like
Okay,
it wasn't
well
ultimate
then
cause or whatever.
let me be a little bit more verbose, because I thought that was implied. So let me give you the more verbose version of the
Horrible
question by what I
assumption.
actually meant. Can you give me a model in physics that deals with the origin of the universe, the emergence of space-time, the fundamental forces, and the phenomenon you perceive in front of you, that does not at its core assume some non-causal backdrop upon which these forces emerge from?
There are past eternal models in physics. It's all very theoretical at this point, but it asserts that the universe just is. It's eternal. So there's nothing outside the universe that causes anything. But I don't understand the question, because I can still do science.
When you say the universe just is, do you mean that it's
exists.
non-causal?
Sure, yeah, it's eternal.
Okay, so when I asked you to demonstrate to me something non-causal, and I asked you to demonstrate something to me that is not non-causal, and then you proceed to demonstrate to me something that you assert is non-causal. How have you met
You
my
want
question?
something that is not non-causal? Okay, Newtonian gravity.
Does Newtonian gravity deal with the foundation of the universe?
That's not what you asked me.
I verbosely asked you, give me a model in physics that deals with the emergence of the universe, how it came about, then the emergence of the natural law, something like, for example, Big Bang cosmology. What does Big Bang cosmology deal with? Does it deal with the rotation of Jupiter? No, it deals with the emergence of the universe. So give me a physical model, a model in...
What are you talking about?
Big Bang cosmology does not deal with the supposed emergence of space-time?
No.
Who am I talking with here? Are you being serious right now?
That's fucking cute, dude. The
I'm
Big
just
Bang
confused.
The Big Bang is not a model of where the universe came from or what created the universe. You could say it's a model that describes, we don't know the state of the universe before the Big Bang, but perhaps it was a kind of universe that didn't have space-time as we understand it. So there's an evolution of the universe, but to invoke that the Big Bang model, I mean, this is what like creationists, they when I talk to them, they're like, oh, so you think that the universe came from nothing? No, the Big Bang doesn't say that the universe came from nothing. It doesn't say that the universe came from anywhere.
You can replay this conversation back. I'm sure someone's recording it.
I'd like to jump in real fast. There are a few super chats directly related to this part of the conversation. Cody H is asking, what's the equation for God in physics?
I don't think there's an equation for God in physics. I think that the properties of God are once again non-causal, immutable, infallible, and these properties exist in every single model of physics as a fundamental assertion and the bedrock upon which the model is based.
Okay. And then Cody H also said, I just want to know how we calculate for God in the current physics models because I have never heard of a physics model needing a God input to work.
No, of course, not the direct like Christian theistic worldview God, but the assertion that there is a set of properties that is non-causal, infallible, and immutable exists in every single model of physics. And I've outlined very clearly that when I say God, and at the most core principle, when people say God, that is what is meant. Before anyone adds his will, his omnibenevolence, his ability to communicate with you, these are all like tacked on after. But if you said, what is P1 of God? P1 of God is that he is non-causal, non-emergent. Then it is necessarily follows that he is immutable and infallible. And so I say to you, the most core tenets of God, P1, P2, P3, are mirrored in physics. They're not mirrored in the laws of physics. It's particularly like electromagnetism and things like this, albeit you can make quite a sound argument for that. They're mirrored in the bedrock upon which electromagnetism is argued to emerge from. And that no matter what angle you perceive it from, that bedrock is immutable and exists across every single model in physics. So when you go property for property, those three core tenets that are attributed to God, those key properties are shared and exist in every single model of physics. And you cannot get around that. Because if you do not assert those as fundamental core tenets, you can make no further progress. It's impossible.
And then Carla J. Strand is asking you to summarize that in 2 sentences or less with no condescension. Can you tell me how the natural sciences point to God? Bet you can.
I think I just did that. Thank you for your super chat. But like, I would just be repeating what I just said. Like literally, I don't think I could do it in 2 sentences unless they were run-on sentences. So I tried.
Okay, thank you. Sorry for interrupting.
It's all good.
2.5 minutes left.
Yeah.
Oh, geez.
It's been an insightful conversation, bro. I think you're an intelligent dude. I think that like, I do believe your position is grounded in some degree of insight. I don't think you just willy-nilly decided to believe this. However, if there's anything you take away from this conversation with me, I would say that investigate that in an honest way. Don't feel like I'm persuading you to do this, but more so for yourself, investigate this idea and find out on a personal level whether what I'm saying has any ounce of truth in it. And if you do, I think that you may reflect upon what I'm saying, and that at its core, and I'll be repeating myself for the 5th time though, is that at its core, all models of physics assert these 3 key tenets as axiomatic properties of the bedrock upon which then they argue comes some form of emergence. But without that bedrock, there can be no argument such that something can emerge from it. And that is ever so conveniently obfuscated in physics. No one talks about it because, in a sense, you are correct. It isn't really like super insightful. It's like, okay, yeah, sure, like there's a gradient. Okay, and so what? Like, what the fuck is the point of this? But why I think it's pertinent is because that property is reflexive to the primary necessary properties of God. And so, to me, personally, that's a convincing enough argument such that I had to reflect upon my old worldview, and I came to the realization that it is impossible for me to understand the natural world as it is without some agent facilitating this. And that's how I came about my belief. And I try to be as verbose as I can about explaining this, but it's I feel like it's very hard to get this idea across to people whenever they are not in an open state of mind. And furthermore, I don't think I myself would be convinced by somebody presenting this argument sufficiently in some debate. I truly believe that God's nature is self-revelatory, and that anyone who comes to God comes to him in their own time. and on their own terms. It's never something that you're like publicly like, oh my God, holy shit, you're right. I'm going to be a fucking theist now. That I have never seen that occur. And anytime I've seen that occur, it's kind of like it's just an act. So, yeah.
All right. And that is, oh, sorry. You can finish up. That is time though. So go ahead and make your statement.
I want to. Oh, I was just going to ask a question. What do you think the Big Bang is? I'm still confused.
Well, you are correct that the Big Bang is the assertion that it's there's some state of affairs beyond which we cannot go, and that state of affairs is attributed to be a singularity, homogeneous state with no ability to discern one from the other. Now, the Big Bang is the argument for the emergence of space-time and the emergence of the four fundamental forces, which is what I'm saying to you. Could there be any argument purported of the emergence of these things that doesn't assert something at its core that is non-contingent, immutable, infallible? And Big Bang does that. It asserts that the singularity has these properties, that it is non-emergent, non-causal, and that it's fundamental,
no.
and that there's, again, some gradient upon which there's a sufficient fluctuation to occur such that there's an expansion of space-time.
That's really not accurate. Like, do you know what inflation is?
Inflationary, yeah, model, sure, yeah.
Okay, inflation precedes the Big Bang. It's not actually part of the Big Bang model. So, like, the Big Bang does not actually include whatever created the matter asymmetry, for example, or like what the universe was doing before the Big Bang. Like, we don't even know if inflation happened. It's just it's a kind of like mathematically convenient for the observations that we make, but we don't know with certainty that it actually happened. But Big Bang, and
I gotcha. Can I interrupt you? Just
yeah, I just have one more sentence. But physicists also, they don't really use Big Bang. They use lambda CDM. Is the
cold dark matter model? Yeah, I'm aware of it.
Yeah,
the most dog shit Swiss cheese model of all time.
What?
It's a whole different
literally
conversation.
confirmed to a higher precision than almost any scientific idea ever.
96% of the mass is dark matter and dark energy, something we've never measured or observed. That's a high degree of accuracy, you think? The inability to explain...
Was the microwave background radiation the most perfect black body radiation curve we'd ever detected?
Yeah,
Yes.
and it was literally predicted before the CMB was observed because people argued that empty space would have a non-zero Kelvin temperature, that there would be some uniformity to
with
this.
The Big Bang, yeah.
Furthermore, I can cite you papers from May of 2025 from James Webb that are explaining the CMB as an emergent byproduct to the tune of over 100%. They're saying that given the fact that we've observed hypermassive spiral galaxies like MOM Z14, which is Z shifted to the gradient of 14, that's the metric they use. There's even some they argue is 17, but they haven't confirmed that because it's too ridiculous of a claim to make right now. So, but they are on the verge of supposedly confirming this. The ones that have been confirmed is MOM Z14. It's aged 280 million years after the Big Bang, and the observation of MOM Z14 fully accounts for the observed CMB we see today. And so I'm telling you, current observations from James Webb are truly throwing a fucking monkey wrench into Big Bang cosmology.
They absolutely are not. The mature galaxies that are very old. Do you know about stellar mass indexes?
Sure.
What are they?
It's pretty self-explanatory. It's an index of stellar mass. It's an index of stellar mass.
You have no idea what a stellar mass index is or what it's used for.
To measure the mass of a galaxy.
Kind of.
That's what it's used for, literally. And any other stellar object that effectively can be subjected to this index.
And you don't use
this
stellar
index
mass indexes for individual stars, no.
For hypermassive objects, sure, not stars.
Right. Okay. So
you're talking about things
before James Webb, what did we base our stellar mass indexes on?
Not particularly sure to be the
The
specific answer to
composition
that.
of stars in the Milky Way galaxy, which
Hmm.
the idea that the Milky Way galaxy has a stellar mass index, just like every galaxy in the universe, is actually kind of preposterous. But it's we live in that galaxy, so it's the easiest one to get data to produce a model for. And then yeah, we saw these very large galaxies that were pretty old, and they were within the, what do you call them, like the cat ears or the whiskers, like a box and whisker type plot or whatever. They were within the range of error of the slope of the graph, but they were actually like right on the edge of it. And so the physicists were like, well, that's kind of that's that. And like younger, you're not a young, I'm not calling you a young earth creationist, but they jumped on that and said like, oh, but they said kind of the same thing you said, that the Big Bang model is falling apart. It's like, well, no, the data was actually within the range. But then what they did is scientists, this isn't even like remotely, this actually makes perfect sense. In the early universe, the observable universe was smaller. All the matter and
Hmm.
energy of the observable universe was the space between
Closer
it was
together.
closer. Yeah. So large stars would have formed. You would expect to see more large stars. And so
Hmm.
the stellar mass index of early galaxies would be much different than the Milky Way galaxy today. Fewer red dwarfs, essentially. And when you create a model that is reflective of that, then that data from those early galaxies fits perfectly within it. Not within the margin of error, but it fits within it.
Okay,
Do you
let's
think
go tit for tat then. What is redshift calibrated to? The Z shift of galaxies.
what is
I
the
already gave
redshift?
you the answer.
What is the
Yeah,
redshift calibrated to?
correct.
We make the calibrate. We use standard candles to make the calibrations. I think that's what you're asking.
And what are these standard candles called? What are they?
Well, there are different types, but type 1A supernova, those are the only ones I can remember off the top of my head.
Okay, good job. You know that. Good on you, bro.
Yeah. Do you think that
Um,
the Big Bang is false? It seems like you do.
I don't think it's false. I just think the CMB is perhaps not a remnant of the Big Bang. And if the CMB can be argued to be not a remnant of the Big Bang, as the papers I'm pointing out to you are in 2025, May of 2025 have been published, then the primary piece of evidence for the Big Bang becomes dubious. And then the Big Bang argument somewhat is on shaky grounds. So that's where
Yeah,
the
I'm confused. You were saying that one of those early galaxies is the source of the CMB?
no, that they have observed enough of these that in collection they can account due to the fact, again, as you said, the space between these galaxies would have been far closer in between,
Yeah.
that because they're so much closer in between, that there would be some uniform heat distribution between them that would then propagate as space would stretch, and that propagation is what we account to be the CMB, due to the fact that these galaxies are so much closer together. And we've observed enough galaxies that are Z shifted far enough and are fully formed at this point, then the observation of merely these galaxies and the assertion that space was much closer together can fully account for the CMB. There's a paper I have saved on this that's published in May of 2025 that goes in depth describing this proposition. So,
Yeah, you should talk to my friend who's a physicist, because he studies, like, specifically he does black hole cosmology. So he doesn't do like material physics or like geology physics. He's like a astronomer. So you'd have a lot of fun talking to him.
All right, all right. So we did have time about 5 or so minutes ago. So
Yeah,
yeah. So let's get into closing statements here. I'm going to end this portion though with nobody on fire saying majority of cosmologists do not think the Big Bang was the start of the universe. Thank you for the super chat. That's greatly appreciated. You all will have 8 minutes for your closings. And there's one more super chat we'll address before we get into this. Anna Monophobic. I don't even know how to say that. Chad, have you read any of these papers you mentioned past the title? What about the abstract? Can you give one thing you've learned from a deeper read?
yeah, I mean, I've read more than the abstract, of course. Have I like parsed through every single statement therein? No. Insofar as the paper I'm talking about in regarding Mom Z14, It's pretty straightforward. Like I said to you, it's an observation of something that is Z-shifted and argued to be 280 million years after said Big Bang. And first of all, the formation of this forces the lambda CDM model to be even more top heavy than it is, meaning that the argument that the formation initially of all of this baryonic matter and stars and etc. was happening at a much faster rate, and that this rate then declined over time. So that's called being, as I understand it, being top heavy. So it forces the lambda CDM model to be even more top heavy than it was already assumed to be, which is kind of like pushing it to a boundary where it's starting to become somewhat irrational on just like a gut level, right? Then the deeper implication of this is, again, the kind of the monkey wrench it's throwing at the CMB, because it's offering an alternative explanation to the observed CMB. And if that alternative explanation is grounded and can sufficiently be demonstrated with observations of further and even higher Z-shifted galaxies, then it leads credence to the fact that the CMB is not what we assert it to be, a remnant of the Big Bang, but perhaps it's merely a remnant of early galaxy formation. And if that's the case, then our ability to even date when said Big Bang occurred becomes incredibly dubious, because the method by which we attempt to date it is in virtue of the CMB, or in large part in virtue of the CMB. So,
Chad, are you talking about a P less than 1/10,000th detection of cosmic microwave background cooling in galactic halos and its possible relation to dark matter?
I don't think that's what the paper's called. Off the top of my head, no.
Okay.
I can give it to you if you want it.
The only thing I can find about this is they think that photons being exchanged between galaxies, like in this like galactic halo or something like that, is part of the cooling measurement of the CMB, but it's not what produced it. It would basically just be like part of the explanation for why the temperature is what it is because of this effect. But it's like, so our measurement is like,
they assert that the margin they give in the paper is kind of wild. I remember them. I don't remember what the lower constraint of it is, but it's somewhere around like a single digit. It's like 5 or 7% of the CMB, and then they say upwards of 100%. So they give a pretty fucking wild margin for like the degree to which this early galaxy formation could account for the CMB. But it's at its most extreme, they argue it holistically accounts for the CMB. And I think that you would be able to find it if you just Google MOM Z14 CMB James Webb. I'm pretty sure you'd get that to come up for you. It's also like, I genuinely think maybe like fucking 20, 30,000 people ever have clicked on this link, if that. So I don't know if it'd be the first thing that comes up on Google.
So with that, let's go ahead and move into the closings. Any more super chats are going to have to wait till the open panel. There will be an open panel after. Y'all are welcome to stick around for that or head out, whatever y'all need to do. But Chad, you open you're the affirmative, so you're going to go ahead and do your closing now. Let me know when you're ready, and I'll start an 8-minute timer.
Right. Well, first, I'd like to thank Planet Peterson. Right? Planet Peterson. You're a cool dude, bro. Keep it up. I think what you're doing is at least provoking thought in people and getting them to critically analyze their worldview, if nothing more than that. It's been a nice time talking to you. Obviously, I don't think you or I were going to convince each other of our seemingly diametrically opposed points of view. So in that respect, just thanks for being a good interlocutor. As far as my sentiment about my proposition, truth be told, I think I've summarized it rather well, and I guess I can try to do it one more time in basically stating that no matter what lens of physics you attempt to perceive the world through, model it from, there is an irreducibility in those models which asserts some property being immutable, non-causal, and non-emergent. And on the most holistic top-down level, when you understand the ontologically necessary properties of God, it is that he is non-causal, immutable, and infallible. And if these properties are reflected in any single model of the natural sciences and of the emergent world we see around us, to me, that's personally convincing enough of the fact that God is real. Um, Obviously, there's people who make quite sound arguments from fine tuning, even just the beauty and the observed harmony of life around us. I think there's also very sound arguments that I never got to make in regards to Platonic objects and how we know, for example, the perfect properties of a square and how we can know these perfect properties ontologically speaking, yet these perfect properties aren't mirrored anywhere in the physical world. There's no perfect right triangle, perfect circle. So I do think there's other arguments that I could have made that, you know, I guess given the topic we're discussing, kind of never got across to. There is no one all be all statement I can make that will holistically encompass my worldview. It truly is something that has taken me well over a decade to formulate, and I cannot imagine a way in which, at my age, I'll be able to translate or meaningfully get the audience to understand what I'm saying. But the spirit of it is effectively that there is some delineation between this and that appears to be not only non-physical, but immutable and non-causal. And if that is what the investigation of the natural world has led us to, the only natural question thereafter is what constitutes that delineation. And for me, on a personal level, it is insufficient to say that delineation exists simply because it does. To me, it's much more of an holistically encompassing, convincing, and maybe even personally affirming kind of argument that there is something that must have properties of being immutable, non-causal, infallible that constitutes that delineation. And when I investigated what theologians and philosophers of antiquity have attributed these properties to, they have always attributed these properties to God. And so being respectful to the forefathers and the giants, intellectual giants upon the shoulders of which we stand today, and even have the ability to make these arguments and the tools that we have at our disposition, I find it to be intellectually credible to give them credence and to call this entity, this set of properties, to call it God, as they were the first ones to intellectually deduce the necessity of these properties and to call it God. So, in short, I think that is a pretty concise summary of my opinion. Obviously, there's a lot more detail to it, but I spare you guys my conclusion. And thanks for having me. Maybe I'll come another time. Who knows?
Absolutely. Thank you so much for coming up, and thank you for the closing statement. Don't forget, guys, there is a vote in there after Peterson or Eric finishes his closing statement. We will go ahead and announce.
I know what you guys think, bro.
We'll announce the master
echo chamber.
Actually, it's about 50-50 atheist. Let me know when you're ready, Eric, and I'll.
Sure. I just kind of have some bullet points. I guess I'll try to make this sound like a coherent thought. So I didn't know what direction this was going to go in. So like that it was so like physics heavy is like, I don't know. Like I didn't know what I was in store for, I guess. But we've heard that, you know, like whatever physics leaves unexplained is best identified as God or by God. But every step of that argument It either rests on provisional scientific assumptions or it relabels physical structures as like divine. Where am I at with my notes? Sorry. So if we call each new backdrop God, then I think we're just moving the name around. We're not discovering any kind of like necessary being or anything like more deeply hidden. We're just sort of sharing a label of something we already know with God. And the deeper lesson is the fact that every model that we have, it starts with some assumptions, but that doesn't prove that those assumptions are immutable. In fact, they have changed over time because that's the nature of science. It doesn't prove that they're non-causal. It doesn't prove that they are personal or revelatory or anything like that. So it shows only that our explanations start from what we currently know, and those foundations have always turned out to be provisional. If we're looking for an ultimate explanation, the honest answer today is we don't yet know. To equate the changing fundamentals of physics and the nature of science with an unchanging divine being, I don't know. It seems like some sort of weird category error to me. That's just how I feel about it. That's the vibe, I guess. The pursuit of explanation, it goes on. It's open-ended, and with science, it's self-correcting. And I don't think that any of this points to any sort of immutable, infallible, ontologically necessary being or deity or anything like that. And that's all I don't know. That's all I can think of.
We do have the vote that's been going for a little while. I put it up before the closing started. I'm going to go ahead and end that now. Also, we're at 18 out of 20 for the super chat goal. Teamwork makes the dream work. We're almost there, people. Now, tonight's master debater, as voted by the audience, was Planet Peterson with 88% of the vote. Chad's status ended up with about 12% of the vote. So congratulations on your master debater status, Planet Peterson. Now, as the master debater for the evening, Eric, you do get to choose a
I get to
Bible
goon on
verse.
screen.
Please don't do that. That's not what master debater means.